Yo guys, and welcome back to another video and a new series on this channel. So what is this project we're doing, I hear you asking? It's going to be a Kahoot clone. You know that quiz platform where someone hosts a game on a massive screen and everyone can join in on their devices? That's what we're making. It's a good learning project because we cover a lot of different topics. We're going to set up both front-end and back-end and communicate between them. So we're going to make a full stack application. We're also going to set up an API that the front-end talks to with CRUD, create, read, update, delete, and databases because we need to actually store our data somewhere and we're going to be storing it in a database. We're also going to be using WebSockets to give us real-time communication between a client and server. And we're also going to touch a bit on game logic. So we're going to have a good blend between web development and actual game development. A lot of good topics that you will have learned about after watching this series. So this is the technology stack that we're going to be using. MongoDB, Golang, Svelte, and Tailwind CSS. So what is this MongoDB and why does it have such a funny name? It actually stands for humongous. And the reason we're going to be using MongoDB is because it's a NoSQL database. So instead of writing weird SQL queries, we're just going to be using a format that we are quite used to. Pretty much JSON. So we're going to write the documents and store them in collections. No need to have any tables anymore. And since we have a bit more complex data structures and varying data structures, it's actually quite an advantage to use NoSQL because it's much easier to model it. And we're also going to be using Golang. It's really popular right now and for very many good reasons. It's a pretty easy language to learn. There's not that much syntax to learn, and so it has a pretty low learning curve. And everyone likes to use it, so we want to stay cool on the block. And look at this cute gopher. How could you say no to this cute little guy? And Svelte. Why are we going to be using Svelte instead of React or Vue or Angular or something else? Well, it's quite literally my personal favorite. So with Svelte, we have a really declarative approach. We write the code kind of like we expect it to behave. It's pretty easy to learn Svelte. And we're also not going to be dealing with stuff like a virtual DOM, which exists in frameworks like React, for example. We're actually going to be compiling our Svelte into vanilla JavaScript that speaks directly to the DOM. So whenever we update a variable, we're just going to be setting something, just like you would do with vanilla JavaScript. Pretty much the most optimized way of doing things. We're not going to have that much of a runtime overhead that we would get with virtual DOMs and stuff like that. And Tailwind CSS. Why are we going to be using Tailwind CSS? Well, instead of writing this fat code block of CSS, we're just going to be writing it in documents. So this will help us prototype and get stuff up and running really easily. So Tailwind CSS allows us to write all of our CSS practically in the classes. And we have a lot of these different utility classes that we can use to have different effects and different colors and rounding. And it's pretty much straightforward and easy to build a UI with the help of Tailwind CSS. So this video is just going to be a quick little short introduction and getting started. We're just going to set up the project, install all the necessary prerequisites. So first and foremost, we are going to be installing Svelte. There are really two main variants of Svelte. It's Vanilla Svelte and Svelte Kit. And if you don't know, Svelte Kit is actually using server-side rendering as well. So with Svelte Kit, you're practically running a server and you can run different backend functionality together with your front-end functionality. But that's not what we are going to be doing in this series, since we're going to have a backend in Golang. So we're going to be using vanilla Svelte for this. And as you can see here, there are alternatives to Svelte Kit. And we can actually use Svelte with something known as a Vite. So what does this Vite do for us? Well, mainly it helps us bundle our application. So we bundle all of our application code into one fat JavaScript file and one fat CSS file and one HTML file. So that way we can easily distribute our code to the client. But we also have something known as the development server, which is incredibly useful, and one of the main reasons that Vite is so popular right now is because you can actually have hot reload with your code. So if you write a change in your code, you'll get that instantly reflected on in your browser. So you don't have to go through the pain of rebuilding every time you edit one single little line. And before you install Vite, it's also recommended that you install a Node.js so that you can run npm. Node.js is practically running JavaScript on your computer. Instead of running it in the browser, we're going to be executing JavaScript on your computer. And that's also what Vite and other packages use internally. You can install Node.js for your operating system by visiting this page, nodejs.org, and probably want to use LTS here and install it for your operating system, and make sure to also install npm together with it. I think there's some checkbox or something which you can check to make sure that you're also installing npm. So now that you have npm installed, let's go ahead and run this command here to install Vite. And I'm going to be using VS Code as my code editor because it's really popular and it's also supported on very many platforms, and we have a lot of extensions that we can use to make it really powerful. So let's go ahead and create a new terminal where we can run this command. So I'm just going to execute this command, npm create Vite at latest. This will install the latest version of the npm package Vite. So we're installing create Vite script, and then we get to name our project. I'm actually going to be naming this frontend, since this is going to be the frontend part of our full stack application. We're also going to have a backend in this same folder. So if you notice, I'm inside of this folder here, Quiz Platform, and I'm going to create a new folder by this command called frontend. Boom. Then we get to choose our framework, and we're going to be choosing Svelte for the reasons that I mentioned earlier. And then we get to select a variant, and in this case we have TypeScript, JavaScript, or SvelteKit, which I also mentioned previously. But we're going to be selecting TypeScript here because TypeScript really provides more type guarantees. It's more strictly typed, and we get much better type checking. So you can kind of guarantee that a variable will have a certain type and make different assumptions based on that, all making it easier to detect bugs. So let's select TypeScript here. And boom, you can see that it's scaffolded a new project in Quiz Platform frontend. So let's open this with a VS Code. So here we can see that it generated a bunch of files, and we have a lot of interesting files here. But the main entry point here is actually main.ts, and this is where the magic begins. This is where we create our main component that we have called app.svelte, and then we're just gonna be rendering that app component inside of the app divider. So if you notice here, we have index.html, and this is our main HTML file. Since we're building a single page application, we have just a single HTML file where all the magic happens, where everything is rendered. And we render our application inside of this divider here. Make sure that you also install this extension Svelte for VS Code. So this is our main Svelte component. And as you notice, we have three main parts here. We have our script tag, we have our HTML, and then we have a style tag. And in the script tag, you can pretty much write vanilla JavaScript, but also with a bit of magic Svelte syntax. And the same really goes for the HTML. So you can see that this pretty much looks like vanilla HTML, but with a bit of different syntax. We also have these curly braces, and this pretty much denotes that we're going to have a JavaScript value here. So in this case, we have a Vite logo and a Svelte logo that's imported within our script here. But we also have child components. So as you notice here, we have a counter, and that's not a vanilla HTML element last time I checked. And that's because we're actually putting another component inside of this component. So you have a child component, and that's kind of the point of working with components, is to keep things pretty small. Try to keep a single responsibility as much as possible. We do not want a gigantic app.svelte where everything is going on. And then we also have a little style tag here, and this actually provides isolated CSS, which is something that I will touch on more in a future video. Let's first go ahead and do npm install to make sure that we install all of the required packages. And then we can do npm run dev to run the Vite development server. And as you can see now, we have created a new server running on port 5173. So let's go ahead and visit that in our browser. Vite plus Svelte, and here we can see our beautiful little counter component as well. And what does it do? Well, it increments this value here and updates that button. So let's take a peek inside counter.svelte and see what's going on. Does this look that terribly scary? I wouldn't say so. It looks pretty straightforward to me. So we have our button, a normal HTML button, but we actually add an event listener on this button. Just like you can do in vanilla JavaScript, we can add an event listener for the click event. So whenever the button is clicked, we want to bind this to a function. In this case, we bind it to this anonymous function. This might as well be the more old school function increment. But what happens inside of here? Well, we're just reassigning to this count variable here. Count plus equals 1, and boom, Svelte knows to update this code. Svelte just knows that, hey, I want to show the value count here. So whenever we update it, boom, it will just do that for us. Isn't that beautiful? So that's a quick little crash course into Svelte fundamentals, but let's also install our backend. So we're going to be installing Golang, and you can install this here on go.dev, and we can go ahead and download it, and the same thing applies here. You install it for whatever operating system you are using. So when you have installed Golang, let's go ahead and create a new folder here called backend. And let's move into it here in our terminal. And here we're going to set up our Golang project. So we're going to be doing go mod init. And here we're going to specify our package name. And I think the convention here is to specify this with a domain. So in our case, we're just going to be doing something like quiz.com, since we don't have a domain yet. So quiz.com and this, and then slash the name of our package. We can also prepend here a version, but in our case we're just gonna have this version. So quiz.com/quiz, and boom. So this go.mod was created for us, and this is where we also can see different packages specifying Golang version and stuff like that. As you might have noticed, we had a nice little warning here from VS Code that we haven't actually installed all the necessary tools. So let's go ahead and do that. Update these tools. All tools successfully installed. You are ready to go. Something that I did not mention is that you might also want to install these extensions like Svelte for VS Code and the Golang extension. That is definitely necessary if you want to be using this in the VS Code. So now that we have that, let's go ahead and create our first Golang file. We're going to be naming this main.go. First, we need to specify our package for our file. This is something I will mention in the next upcoming video, but for now we can just make this a main, since this is our main package. And then we want to have our main function. This is the first function that will run in our application, and we need to name that main. And then we can go ahead and write to the console fmt print line to write to the console. And of course, we're going to be writing hello world. What else? So if we open up the terminal again, we can do go run main.go, and boom, we get hello world. Isn't that beautiful? And now we have our front end and our back end up and running and ready to rumble. So in the next video, we will start by setting up our back end to also include a HTTP server, so we can start working our CRUD. We're also going to set up our database and start communicating between the front end and the back end. We'll set up Fiber, MongoDB, WebSockets, and start communicating between the client and server. In the last video, we set up our Svelte frontend and our Golang backend. Make sure to watch that video first if you haven't seen it. First, we'll set up Fiber, which is going to be our backend HTTP server. But what is really a HTTP server? HTTP is the protocol that powers the web. It's what lets you visit YouTube and watch this amazing video that you're watching right now. It's how the client, your browser, and the server communicate. When you visit a page, your browser makes a HTTP request to fetch that page. And then the server returns back a HTTP response, which is often HTML, but it can also be assets or scripts which are necessary to draw the page. But HTTP requests can also fetch raw data. You can send back practically anything in your HTTP response. Traditionally, a lot of pages used server-side rendering, where you would make one single request and the browser returned back new HTML page. But that meant that you needed to reload the page to actually see the changes. And that's not something we want in a native application. It is 2024 after all, and our browsers are becoming more and more powerful, and we kind of want our websites to feel more like an application, especially a quiz platform which is going to be really interactive. This is why we are making a single page application. This way we will instead let the client do all the heavy rendering work with Svelte. And we will instead make requests like fetch the quizzes in the background without reloading the page. And then when that response comes back, we will simply let Svelte render it. As with all libraries, there are a million alternatives out there. There's Gin, there's Echo, and Golang even has their own built-in HTTP server, if you're a daredevil, that is. But I chose Fiber because it's very easy to set up and has a lot of small components known as middlewares that are practically extensions to our HTTP server. So let's go ahead and install Fiber. I want you to look at that, a neat little code snippet that we can just copy paste into our editor. Let's go ahead and do that. And we also need to install this package. We can fix that with a quick fix, control plus dot, go get package, which will fetch this package. And there we go. Now it has installed that Fiber package. Then let's run our application again. You can see that it found a HTTP server here on port 3000. So let's visit that in our browser. And there we go. Now we have Hello World v2 instead as a HTTP server. Isn't that amazing? So let's take a look at this code. What is it really doing? First and foremost, we create a Fiber instance, and this is just a simple way to declare a new variable in Golang. We declare and assign a value to the variable at the same time, and we just use the Fiber package.new to create a new instance here. And then we set up a route. I'm sure you've seen them in your browser before, something like post/1337 or something. We just have this root route here. This is our main index route, which you can see here, which is what we specify here as this string. And then we pass in a callback function. And this callback function will run whenever a request has been made to our HTTP server. And this is just a fancy way of doing this anonymously without giving this function a name. It's equivalent to this where we create an old school function and also give it a name. So this is the function signature that Fiber expects for a handler. So this is what's known as a handler. It's going to handle incoming HTTP requests to this specific route. And this signature is always going to be the same. We're going to pass in a fiber.ctx, and this little star here simply means that this is a pointer. It's actually a reference to a context, which means that we can mutate it or change it. And now we simply return back an error. This lets us return errors from our handlers and then let Fiber handle them. It's also quite a nice way of just using return. We can just return here since this will actually return an error. So this fiber.ctx is really the holy grail of the Fiber handler. This is where we do everything. We can send back a string, so we handle both the request and the response in this context. So in this case, we're sending back a string as our response, but we could also do something like c.query in order to fetch a query parameter from the request. But what if we wanted to have a different route, say a list of quizzes? Let's do that. So now I've defined a new API/quizzes route and created a new function for it. What are we going to return inside here? I think we're just going to start off with some dummy data, and we want to return JSON here. So there's actually a function for that in this context known as JSON. So we can do c.json, it will send back JSON. It will also set the content type headers. So there are headers in your HTTP requests and responses, which kind of tell information more about the request or response that's coming, and one of those is content type. So we specify the type of data that we are returning, and when we return JSON, we return with the content type set to application/JSON. And into this JSON method, we can actually send in any data. So we could send in a string, or we could send in a number. And that is due to the fact that this JSON here actually takes in interface. And this interface, it has kind of a weird syntax, but this simply means any type. So since AnyType actually implements an empty interface, then AnyType is simply an empty interface as well. So in our case, we want to return a list, and a list in Golang is known as a slice. So there are also arrays in Golang, but they are more fixed length and kind of hard to work with. So we want a dynamically sized slice. And the syntax is a bit weird here. We first specify our square brackets, and then we specify the type of the array. And in this case, we want to return kind of like an object. So we're going to return a map. So we're going to return a map, and then in another pair of square brackets, we specify the key of the map. In this case, it's going to be string. And then we want to specify the type of the value. And in this case, we're going to have any value. So I'm going to put any here, and this is simply like an alias to this interface thing that I mentioned earlier. So let's create a new variable. Let's declare a new variable just like we do here. So let's just do list, and then we declare that here. And then we can use curly braces to initialize our slice. And in here, we are going to put a map string any, and then we use curly braces as well here again. And then we can actually start writing our map. So I'm just going to put something like test 1, 2, 3. And we actually need to put commas after each of these entries. But now we can see that kind of worked, and we can pass in now list into our c.json. Let's go ahead and try this. And boom, this is the response that we get when we query API/quizzes. And we can see that it's also doing this JSON formatting just because we have that content type set to application/JSON. But if we take a look at the raw data, this is just like we normally expect JSON to look like. And also a nice suggestion here, we don't actually need to write this type twice since we have already specified it here. It can be inferred, so let's just get rid of that. Now that we have a HTTP server up and running, let's also get started with storing some data in a database, our MongoDB. So what really is MongoDB? MongoDB is known as a NoSQL database. Traditionally, a lot of databases were relational databases and used SQL to query them. Data was stored in tables, and that had a pretty rigid structure. Wanted to store a list of something, you would probably have to split it up into multiple tables. With a NoSQL database, however, the data is stored in a format that we are more used to. We can just slap a fat list of objects into another object and call it a day. This works much better when we have a lot of dynamic data that can change structure over time. Instead of tables, we store documents inside collections. So how do we get MongoDB up and running? There are really two main ways we can go about it. We can either use the open source community edition and run it on our own machine, or we can run it in the cloud. The creators of MongoDB actually provide their own cloud environment known as Atlas, where you can get up and running very easily. They even offer free accounts for testing and small hobby projects, so it's definitely worth checking that out. I'm going to go with the self-hosted variant though, since we get a bit more control over our data then. This can be installed very easily by visiting MongoDB's website and following the installation instructions for your operating system. Now that you have MongoDB installed, you can use the Mongo shell to connect to it. We're going to create a new database inside our database and call it quiz. This can be done by running use quiz, and then we create our first collection here using db.createCollectionQuizzes. This collection will contain all the quizzes that users have created. And we're also going to go ahead and install the MongoDB Golang driver. This will let us actually connect to our database within our Golang code and communicate with MongoDB through Golang. So let's run this go-get command to install that package. And then we have a neat little code snippet here that we can use. And here I defined a new function called setupDB, which will be our database initialization code. And if you notice here we are actually connecting to the database using an URI. So in this case, I am actually hosting this MongoDB instance on my own machine. So I'm going to use a local host here and then the default port for MongoDB. If you're hosting through Atlas, for example, they also provide URIs, which you can just paste into here to connect to your database. But make sure that you do not publish this code anywhere. You do not want to publish your database credentials. So in an upcoming video, we'll also take a look at environment variables because we don't want to store our connection URI directly in the application code. So we try to connect to this database, and if the error isn't nil, if there actually is an error, then we panic. And panic in Golang simply means that we crash the program. We do not want to continue normal execution after this point. We just panic, crash with this error and display it to the console. Otherwise, we get this client instance, which is where we are actually going to communicate with the database. Then I use that client to actually access that database that we created previously, this quiz database, and then I access the collection quizzes. I'm just going to use a global variable for now. That is definitely not the best practice, but we want to be able to access this variable from within our handlers as well. So just assign this global variable, which I define like this, Mongo collection, and I assign that to this quiz collection. So then let's also place setupdb in our main function so that we actually set up the database, and then we can start using this collection here in our handler. So what kind of fun stuff can we do with a collection? Let's take a look. Quite a lot of methods here that we can use. But in our case, we actually want to get a list of all the quizzes in the database. And we can do that with the find command. So these are the parameters of the find function. First, we need to pass in a context. If you don't have a special context already, we can just use context.background. And then we need to specify a filter. So we can filter these documents that we return based on a specific query. Say that we wanted to find all the quizzes that belong to a specific user. Then we can do that with a filter. But in our case, we don't want a filter since we want to get all of the available quizzes in the collection. So we actually use bson.m, and this is just an alias for a map in Golang. So this behaves just like a map, but this is specific to this bson package. So in our case, we specify an empty map because we don't have any filtering that we want to do. And what does this find method actually return? It returns a cursor and an error. So let's assign that. So we get back a cursor and an error. First, we need to check if there's actually been an error. So Golang doesn't actually have this try-catch construct where you could like jump multiple levels of program flow when an exception occurred. We actually need to handle it where it came from, and then we can pass down the error to other functions and stuff like that, but we get back an error in here and we cannot really catch it. So the best practice here is actually to handle this error, but we are just going to panic here. So this cursor is actually useful if you're working with something like pagination, where we have like multiple responses and different pages and stuff like that. But in our case, we just want to fetch all of the available quizzes. So we can just do cursor.all. And then we also need to specify context. So context.background again. And here comes an interesting aspect. Here we need to specify a results interface. So this is going to be an actual type that we decode into. We can actually decode directly into a Golang type. In our case, we're just going to decode into this kind of map that we had previously. So actually a slice of maps. And we're going to take a look at how to do this properly in the upcoming video. But for now, we're just going to have a slice of quizzes. And then we need to pass in a pointer to this slice. Since the driver needs to be able to mutate this slice, we need to send in a pointer so that I can actually mutate this specific quizzes variable that we have here. And this, of course, also returns an error, so we need to handle that. And notice when we use this syntax, we cannot actually declare this variable because it already exists with this name. So we can just reassign that previous variable to error. And now we should have all of the quizzes stored now in this slices. So instead of returning this dummy data, let's return our quizzes slice. So if you visit this API/quizzes route again, we get null, and that is because we didn't actually receive any quizzes here in our case. So we probably want to initialize this quizzes slice as well. So we can do something like this. Then we use curly braces again. So the actual problem here was that this variable was only declared, but we haven't actually provided a value for it. So it was actually nil, since the default value of a slice in Golang is nil. We actually want to assign this to an empty slice. Let's try that again. And now if we take a look at the raw data, we can see that we get back an empty array, which is what we expect since we haven't actually created a quiz yet. So let's go into our database again and create a quiz. We can do that with the insert command. So we can actually do db dot, the name of the collection, which is going to be quizzes, and then insert one. And this is where we also specify with curly braces the start of the document, and then we can write some data. So let's try name hello world. Boom, acknowledge, and we inserted that. And let's try running this again, and boom, won't you look at that, we actually get some data. So now we have successfully stored our first quiz in our database, and we're using the Golang driver to fetch that from the database. This is all great. Now we can access the list of quizzes from within our browser, but that's not a lot of fun because we wanted Svelte to be fetching that list of quizzes, right? I doubt any user would be that impressed with this plain JSON array of quizzes. So how are we going to use JavaScript to communicate with the backend server? There's actually a really neat built-in API in the browser known as the Fetch API. Pretty sensible name, right? With the help of the Fetch API, we can let the browser make a HTTP request in the background without reloading the page. Then we can read and parse the response, and voila, we are successfully communicating between client and server. There's one small concern though. Suppose we have a bank HTTP server that lets us do actions like withdrawing and depositing. If we can just use JavaScript to make arbitrary HTTP requests to a URL, what really prevents a hacker from creating a script on their page, which then forces your browser to make a HTTP request to the bank server and steal all your money? Thankfully, we have a solution to that called CORS. It stands for Cross-Origin Resource Sharing, and that's exactly what we're doing, cross-origin requests. We should be very thankful for this CORS thing, but it actually causes a bit of a headache since we have our Vite development server running on a different port than our HTTP server. We actually need to set up CORS headers, which will tell the browser that it's okay for our non-evil Vite server to make requests to the backend HTTP server. We can fix this by installing a middleware to our Fiber server. And like I said previously, a middleware is like a small extension that runs before or after our own handler. In our case, the CORS middleware will simply prepend a header that will allow cross-origin requests from our Vite server. Fiber has a nice little documentation page of this. We can simply add a bunch of import statements and then do app.use CORS.new, and this will allow any remote server from making cross-origin requests, which is definitely not a good practice. But this is not a problem in practice though, since we're only going to use CORS in development. Our production build will run the front-end code on the same server as the backend, so we won't even need CORS then. So now that we have CORS set up, let's finally use the Fetch API inside our front-end application. And to do this, we can simply use the fetch function. And the first argument here is going to be the URL which we are fetching. This Fetch API is also running in async, which is sensible since we don't want to block the whole page just to wait for the response to come back from the server. And here I just assigned the response to a new variable called response. Then we can use the OK property to check that we actually made a successful request to the server. Remember that we are also returning JSON from our backend server. So there's actually a nice, neat little method called JSON, which we can use on this response. And this will parse the response into an actual JavaScript object. Isn't that neat? Let's just add a console log here to see what we get back. And then let's also create a button, which we can use to press to actually make this request. So get quizzes, and then we can add an event handler to this where we just call get quizzes. So then let's go ahead and try to click this button, get quizzes, and boom, won't you look at that, we actually get back a JavaScript array. And if we expand that, we can see that this is the data that we have stored in our MongoDB database. Isn't that awesome? So now we have pretty much done everything to get up and running. There's only one small detail left. We want real-time communication. So since we just learned about fetch, can't we use that to communicate with our server? There's just one small problem with that. It's a form of one-way communication. What if the server wants to send back that something incredibly interesting happened in the game? We would have to implement a technique called polling that would periodically ask the server, Is there anything new yet? Is there anything new yet? You know, that poor server is going to get very tired of us nagging on it all the time, and it's not that efficient. There's actually a much more suitable technology called WebSockets. This will set up a two-way communication between the client and server where they can send the messages simply whenever they feel like it. And this uses the WebSocket protocol as well, so we avoid all the unnecessary overhead that comes with HTTP requests. So how do we set this up within our Fiber server? With a middleware, of course. So we just need to install this package here. And here we have a nice little example that we can use. I'm only going to copy this one since it's the only thing we need. I'll also get rid of this ID param here since we are not going to be using it. And this here's some debug prints. We can probably get rid of that as well. And there we go, that should be everything for our backend. So how do we set it up in our frontend? Well, there's actually a nice little object in JavaScript known as a WebSocket. So I just created a new function called connect where we create a new instance of this WebSocket object. And here I just provide this route that we defined here. So this WS route that we are also using here. And then we can add some callback functions to this object. So we can do on open, and this will be ran whenever we have successfully opened a connection to the server. And of course, we are no longer using the HTTP protocol, so we want this to be WS instead. And then we can do WebSocket on message, and this will be called whenever we get a message from the server. So this will be an event. And we can get information about that message by doing event.data. And then let's also create a new button to connect to the server. And let's try this out. Connect, and it says opened connection. So this implementation that we have here in our backend is actually an echo server. It will just echo back whatever we send to it, so nothing is actually happening right now. But we can send a message to our WebSocket server here with websocket.send. So we can say hello world, of course, and then we can press connect again, hello world, and boom, we can also see that we get back hello world. And if we take a look in the console here for the backend, we can see that we received hello world. So now we are successfully communicating between the server and the client with WebSockets as well. And that is all for this video. So now we are finally set up a lot of the stuff that we are going to be using in this project, and we can start actually working on this quiz Kahoot clone that we are making. But now it's actually time to render our data on the front end. There's actually one little thing I mentioned that we haven't installed yet, Tailwind CSS. If you remember the first video, Tailwind CSS is going to let us create our UI directly from the HTML markup. There's a bunch of advantages to this. One is the incredible speed at which we can prototype new UI elements without ever leaving our HTML. It really plays along nicely with our components because there's rarely the need for reusable CSS classes. We don't have to come up with CSS class names if we try to make our components as small and specialized as possible. So instead of searching through a fat file of CSS and trying to find matching selectors, we can just open up our Svelte file and it's all going to be there neatly packed. So Tailwind CSS is built upon loads and loads of utility classes. Almost every CSS property has its own class. So the difference between this and just writing inline styles is there's a very consistent design system in place, which makes writing CSS a breeze because it's much more predictable how things are going to work. So suppose we want to create a button component with Tailwind CSS. How can we do that? Let's start with a basic button. How does that look with Tailwind CSS? If we just add a simple HTML button without doing anything. Or won't you look at that? That looks a bit different, doesn't it? Tailwind CSS uses something called pre-flight that basically resets a lot of the default styling that your browser sets. And that's also good because different browsers have their own default styling that you probably don't want to keep. So now we have a clean slate to work with. Isn't that nice? So now let's add a color to this button. We can do that with the BG utility, and that stands for background. Pretty sensible, right? So which colors do we have to choose from? Tailwind CSS actually has their own expertly crafted palette built in with these beautiful colors. And notice how the shades change with increasing numbers. Let's try BG Blue 500. Looks good except for the color of the text. We can set the text color with text white. Let's also make the font bold with, you can almost guess it, font bold. Now, in order to add padding, you use the p utility and then a number. And this is the spacing scale which we are going to be using. And these are mostly even numbers, but they are also very predictable to work with, and you can just take a look at this table if you want to know what they actually map to. So wouldn't it be nice if we had a bit more padding horizontally though? We can do that by using px and py instead to add padding in the x-axis and y-axis. And let's also add rounded corners, of course, because it's 2024 after all. Almost perfect, but what happens if we move our mouse over the button? Pretty dull, right? Tailwind CSS also has state modifiers, which lets us apply any style conditionally depending on a state. So let's say we want the color to be a bit darker when we hover over this button. How can we do that? Well, we can add hover and then BG blue 600, and that is the utility that we want to apply when we hover on that button. But it could be anything. We could make it no longer rounded whenever we hover over it, or add a border or anything imaginable. So now that you know how Tailwind CSS works, let's quickly build this button component in our project. So let's first install Tailwind CSS. So Tailwind CSS actually has a really nice documentation which we can follow here. So we're going to install Tailwind CSS with the Vite, and we are using Svelte, of course. So let's start out by installing the required dependencies, the required npm packages, and there we go, we got them installed. And then we're going to run this command npx tailwind css init, and what this will do is actually create configuration files for our Tailwind CSS. So this will let us actually configure Tailwind CSS. You can actually create your own Tailwind styles and modify the existing styles if you want. So it's really customizable, which is nice. So let's run that. And then we can see that it created these files, and we're actually gonna take a look at that already. So we have Tailwind CSS, Tailwind config.js, and we're going to add this content array here. And what this does is simply tell Tailwind CSS where to look for Tailwind classes inside of our project. And we're going to look inside index.html, which is our main SPA file, and also in the sources directory. So this will also work with the nested directories if we have any of those. And it will look for these extensions. We're not really using JSX or TSX, but this should be fine. And the reason we are doing this is because we need to tell it where it can find these classes. We do not want to generate Tailwind classes for every single CSS property, which we are not going to be using. So we need to actually tell it where it can find them, and then it will generate those that we are actually using. And then we also need to inject Tailwind CSS into our bundled CSS file, which is app.css. And there's currently some default example CSS from Vite, but we can get rid of that and copy in this stuff here, which will just put the Tailwind classes inside of this file. And now we can try running it with npm run dev. And if we take a look now, we can see that it doesn't look as good as it did last time, since we got rid of that default CSS. But now we can actually start creating our button component. So let's go ahead and do that. We have our counter component, which is nice, but now we want to have a button component. So let's create a button.svelte. And then we are simply going to use the styles, which I mentioned earlier. So let's do that. So here we go, here we have that, and let's add that into our main component here, button. Let's see, wow, won't you look at that cool little button, and you can see that nice hover effect as well. But it's kind of boring, right, because now we have hard-coded this content here. And how can we do this in Svelte? How can we let the parent component decide what we are going to render here? So there are multiple ways to go about it. We could of course export it as a property. So with a property we can send in a string which we want to be rendered in the component. Let's try that first. So here inside my script tag, I create a new variable. So just like I do normally, let text, and this is just a type annotation in TypeScript. And then we have export, and export is what tells Svelte that this is going to be a property. And it simply says, hey, let outsiders know about this variable. So now we can actually access that outside. It actually complains here in app.svelte. You can see that it says, property text is missing in type but required. So now I can apply text here, and I can send in something like cool. And of course nothing happens since we're not rendering anything yet, but let's go ahead and render that. So we can display some JavaScript variable with curly braces, boom, text now shows cool. Isn't that nice? We can also make our properties optional by providing a default value. So we could provide a default value like an empty string, and then we could get rid of this property here, and it's no longer going to complain, but it's going to be an empty string, and that's kind of boring, right? So let's keep that property, and that kind of works for our purpose. Now we can display a text here. But suppose we wanted to render an icon or an image or any kind of other element inside of this button. How would we do that? We would need to have multiple HTML tags, and for this you can actually use something known as slot inside of Svelte. So we can actually provide slots in our child components, and then whenever we pass in anything, just like you pass in here, connect, this is going to be the content of the button. We can pass in data here, so we can actually press in other HTML or even other components if we wanted. So we can actually put a slot here, and the syntax is just like this. We put a slot like this, and we can see we no longer need this property, so we can get rid of that. So whatever I put here will actually be rendered in the button. So I can do cool button again. I can see that that renders. Isn't that cool? So I could even put multiple elements here. I could put something like hey, and this will be on another line, of course. I could put in a whole list of items like this, and this will also be reset by Tailwind CSS, by the way, so that's why there's no like dot next to it, if you were wondering. But the point is now that we can use slot, and we can also move it around, of course. So suppose we want to have a divider surrounding it, we can pretty much put it wherever we want inside of here. So we can simply put a slot, and Svelte will just copy paste whatever we have here into this slot. Isn't that amazing? So in the last video, we also took a look at how we can fetch data from our backend in our Svelte frontend, and we created this function getQuizzes, which should work now. If I try to click this getQuizzes button, we can see that we get back a JavaScript array. Isn't that awesome? So let's try actually rendering something when we get back this response. So what we're going to get back is an array of objects. So let's just write this inline for now. We're going to create an actual interface in TypeScript for this later, but let's just write the type inline for now. So we can do something like this, quizzes, and it's going to be an object where we have an ID, which is a string, and a name, which is a string, and that all is going to be an array. And then let's initialize it as a default empty array. And then let's here in getQuizzes assign to that variable. So quizzes equals JSON. So now whenever I press this getQuizzes button, we no longer get anything in the console, but we are now assigning to this quizzes array. So it will be filled up with all of the quizzes that we have in our database. So how can we render these quizzes on the front end? We can actually use something known as the each statement inside of Svelte. So the way to do this is actually by using this special syntax. We start with curly braces, which kind of indicates that we're going to do something with JavaScript or doing something with Svelte in this case. And then we provide a hashtag, and then we put each. And after this each, we simply name the variable that we're going to loop over. So each quizzes, and then we say as, and then we specify the name of the temporary variable that we get in each iteration. So for all of these quizzes, we're going to get a new variable that we can assign, just like you do with a normal for loop. So for each quizzes as quiz. And then of course we need to terminate this each statement. We can just provide it /each here. So all the code inside this each block will be generated one time for each of these quizzes. So if I put something like a p tag and then quiz.name, let's try that. So if I press get quizzes, boom, we can see hello world. That is our first and only quiz that we have stored in our database. So if we take a look, we can see that, yeah, it is actually generating a p tag for our hello world quiz. But if we were to have multiple quizzes, we would simply see multiple p tags here. So let's try creating a new component now that we learned a little bit. We can create a new component here, and it's going to be a quiz card. So quizcard.svelte. Then let's start with a script tag. And in here, we're going to take in a property of the quiz that this quiz card is supposed to render. So this quiz card only has one single responsibility, really. It's going to render a card with the name of the quiz that we have. So we're going to do something like export let quiz, which will be our quiz prop. And then the type of this will be ID string name string. And this will be required. We do not want to have a default value for that. And then let's just make a divider for this. Let's put quiz.name in here. And let's start using that component. So instead of this boring p tag, we can use a quiz card component instead. This is actually a shorthand. So if the prop has the same name as the name of the value that you're passing in, we can just do something like this. So this is of course equivalent to just passing it in like this, which we can do as well. So let's try pressing this get quizzes. Now we can see hello world, and now instead we have a divider, which is our quiz card component. So now let's try using some Tailwind CSS here. So we're going to start with BG white, since it will just inherit the background that it's currently on, which is white, but we want it to be definitely white. Let's add a border. So we can do that with border, and then we can specify the width. So if we just specify border like this, it's going to have a width of 1. We can also specify border 2, border 4. We can specify border 2. Why not try that? Then let's try border green 500. Why not? Boom, look at that. Isn't that cool? And then we can try adding some padding. Let's add padding in all directions. So padding 1 rem, padding 4. Boom, here we have some padding. Isn't that nice? And of course, some rounded corners. So let's try something like rounded XL, that is extra large. Yeah, isn't that nice? Now we have our nice little quiz card component, and see how easy that was to prototype. We just had to think a little. How do I want this card to look? Well, I want it to have a background white. I want it to have border 2. I want to have this shade of green. We want to have rounded corners. And boom, we just write. We don't have to come up with CSS class names and start moving things and importing things. No, we just write it, and now we know. And then we just know this divider is going to have this styling applied to it. We don't have to look in some other file to find out what it's going to look like. We can kind of imagine in our mind, but just deciphering whatever stands here. Isn't that nice? So that is all for this video. It's just a short little introduction of Tailwind CSS. So now we can actually start writing some really nice UI for our application. And we also know how to work with components a little bit, looking at how to use properties and stuff like that, and actually using our fetch API to power our Svelte application. It's time to get the game up and running. Since we finally have Fiber, MongoDB, WebSockets, and Tailwind CSS set up. So to do this, we must actually create a data structure for our quizzes. How do you want this data to be stored in our database? Well, we want a unique identifier for our quizzes. We need to be able to tell them apart somehow. And we also want to have a name, which is what the user will be seeing. They will not be seeing this long ID. And since we have unique IDs, the names could hypothetically be duplicates. That's not a limitation that we want to set on our users. And these IDs will be stored in the object ID format, which is an ID format that is created by MongoDB. They are guaranteed to be unique and work very well with MongoDB. Questions. What is a quiz if there aren't any questions? So we're going to store an array of questions on our quiz object. And this is where MongoDB comes in strong, because if we were to do this in a relational database or something like that, we would probably have to split it up into multiple tables. These questions will also have IDs, but we are going to store them in a format called UUID, Universally Unique Identifier. And the reason is that it's pretty difficult to generate an object ID in the browser in JavaScript. But UUIDs actually have a built-in support in browsers, so we're going to use that. Next, another name field, but this will be the actual question name. So if I ask what is 2 plus 2, that is going to be the name of our quiz question. And then for each of these questions, we want choices, the free will to answer correctly or make a fool out of yourself. We're going to do just like Kahoot, 4 different choices where multiple of them could actually be correct. And this is of course something we can change later. Maybe we want 10 choices to our questions. And can you guess what the first property will be on this choice? You're right, an ID. And the name, pretty predictable, right? But we're also going to store a flag called correct. And this will be a Boolean value, a true or false value, indicating if this choice is a correct one. So this is the first version of our new data structure. Let's go ahead and implement it in our backend and frontend. But first we need to learn how to store data like this in Golang. We already know about slices, our dynamic lists of data, and our maps. But how do we represent an object in Golang? We're going to use something called structs. And structs allow us to group together similar types of data. And we can then simply pass around this struct instead of having to send in like 10 different variables into a function. Quite convenient, right? Notice here that the name of the struct field comes first and then the type, just like we're already used to in Golang. We can also define methods on structs, which will let us run functions on a struct and have access to the data that is stored in this specific struct instance. And something worth mentioning here is the importance of pointers. Since Golang is passed by value by default, we're actually sending a copy of the data into functions. Say we send an int to a function in Go and then try to increment it in the function. The calling function will not see this change because we are modifying a copy of this data. And that is why we use pointers. We instead send the address to where this data is stored in memory. And when we mutate this, when we change this, it will modify the actual data at that place in memory. And then also the calling function will see that change. And the same goes for methods on a struct. We can see them like functions that simply take in a struct and does something with this data. If we just pass in a naked struct with no pointer, we are essentially not going to be able to change its value since it's just a copy. If I call this increment function on my struct, nothing will happen. So it's important to make that distinction here. If we want to mutate it, we probably want it to be a pointer. So how do we model our quizzes as Golang structs? Well, it's going to look something like this. We're going to have ID, of course, and this will be of the type primitive.objectID, which we are going to import from the MongoDB package. And then the name of the quiz, a string, and then our friend, a slice of the quiz questions. And here we will be using the UUID package to get access to the UUID type. We're also going to have a game struct, and this will be the struct for our literal game, where all the fun stuff is going to happen. We're going to store an ID, a quiz, a current question, and a code. And the quiz will be the quiz that this specific game is running. The current question will be the index of the current question being shown to users. And then this code is going to be the 6-digit code that players enter whenever they want to join our game. And how do you do this in TypeScript? It's a bit more straightforward here. We just define an interface, which simply says objects of the type quiz should have these properties with these specific types. And this is how that will look like in TypeScript. It's also time to get a bit more structure in our Golang project. There is somewhat of a best practice defined for Golang projects, especially in the folder structure. This might not really be needed for a small project like ours, but it's good to follow best practices since we might want to expand it later. It's a very similar structure. We're going to put our internal code in a folder called internal, and we put all the executable commands in a folder called CMD. And this internal folder will not be accessible if we were to make this an exportable module. Say we made a library that we would share on the internet. So then we want to place our main function in the CMD directory, since that is going to be an executable, and we keep our other code in this internal folder. Subfolders here are known as packages, and it's sensible to group similar code into these packages. When we want to use code from another package, we simply import it, just like we would do with a third-party library. And then the package name becomes the prefix for all symbols inside that package. Say we have a user structure in our model package. Then we reference that by model.user. But if we are writing code directly in the model package already, then we don't need that prefix. So it's time to think a little bit about which packages we're actually going to create. We're going to follow somewhat of a model weave controller design pattern here. We're going to place our representations of data, our literal structs, in an entity package. Then we're going to place our fiber handlers in a controller package, and then more of our business logic inside a services package. And I'm going to create the following services: net service, game service, and quiz service. Net service is going to handle most of the low-level networking stuff with WebSockets, while game service and the quiz service are going to talk with our collections. And for collections, we will have another package called collection, which will speak directly to our MongoDB database. I will also have another package called game, where we will have most of our game logic. So let's go ahead and create that folder structure that I just mentioned. And there we have those folders. Let's go ahead and create the files as well. So here we have our quiz.go file in the entity folder. Let's go ahead and create that quiz struct that I mentioned. And there we have that. Nice. Then let's create the game struct. And then of course, just like I said, we want to have internal and CMD. So let's move all of our internal code into an internal folder. And for the CMD package, it's actually a best practice here to have the name of the executable that we expect to have. So in our case, we don't really have a name for an executable, but we're just going to call it quiz. So the command to run it will be quiz. Then we just name the file the same thing, so quiz.go. And now we can run this project again with go run cmd quiz.go. Go ahead and write some of the collection code. We're going to have a quiz collection, which is the collection where we are going to store our quizzes. So we're going to have some methods here that helps us create quizzes or fetch quizzes or delete quizzes and stuff like that. So if we just start with insert quiz, we can just create an insertion function. And in here, I'm actually storing a pointer to the actual raw MongoDB collection. So you can almost see this as a wrapper around this collection, but we just provide the actual methods that we have defined for our quizzes. And this is how this method will look. We will just be calling the insert one command, context.background, and pass in this quiz struct. And what we get back here is actually a result struct that contains some information about how many things were inserted and stuff like that. But it's not that interesting. We're only really interested in the error. So we get the error from this command and then we also return it back. So this is kind of the best practice when handling errors in Golang. We just pass on the error if we're not handling it here. And we don't want to handle it directly here. We want to just send it up. So we just fetch, if there is an error, we just return that error. So we're going to create a function called getQuizById, which will fetch a quiz from the database depending on its ID. And what we're going to do here is call the findOne command, and what we pass in here is the actual filter. So this time around, we're actually going to have a filter, and we're going to have an ID filter. So we specify this bson.m is simply a map, and then we specify we want this specific property called _ID to equal this ID. So this is just equal. There are other queries like ors or in or anything like that, but this is just an equal. And what we get back is a MongoDB single result. And the rest of the code will look something like this. We're going to use this decode function, which we have used before. This time we're going to decode it into a single struct. This will take whatever data we get from the database and try to decode it into an actual Golang struct. So that is really convenient. We also get back an error here. This error will be passed on. So if there was an error in this findOne command, that will also be returned here. So if this error is not nil, if there was an error, then we want to return nil. We don't want to return any quiz, and we just return the error. And then if there is no error, then we just return a pointer to this quiz that we decoded. And of course, we also want a pointer here when we call decode, since we wanted to be able to mutate this quiz, just like I mentioned earlier. Otherwise, MongoDB would simply be trying to modify a copy of that data. And then we also define a function called getQuizzes, but this instead will fetch all the quizzes from the database. And we have done this before. We used to find all the quizzes, we get back a cursor, and then we just call decode on that slice to actually get back that. And then we just return quiz. So this is pretty much how our collection code will look. So I went ahead and created a controller and a service for quizzes as well. So we just have this quiz controller struct, which we will save a pointer to our quiz service. We just create this function called quiz. So whenever we call controller.quiz, we will be creating a new quiz controller instance. And then we just pass in the dependency, in our case, a pointer to the quiz service. And in here, we just define our fiber handler. So we're going to have our quiz controller, get quizzes, just our normal fiber.ctx. We try to fetch the quizzes from our quiz service, and if that is successful, we return the JSON, otherwise you just return the error. And how does that quiz service look? Well, it looks something like this. We just have a type quiz service struct. I do the same thing here, just a quiz function, which will create a quiz service instance. And this quiz service get quizzes isn't that interesting. We just have entity.quiz. We just return whatever we get from the quiz collection. But in the future, if we want to change something here, maybe we wanted to do some other business logic here before we return it, then we now have it separated from the actual collection code that is speaking directly with MongoDB. So I also switched up my CMD here. I just created this little function main where we instead use internal.app. So I've actually created a struct here in app.go. So now we just have the bare essentials for starting up the app here in quiz.go, but the actual app will now reside in app.go where we will have this app struct. And instead of this main function, we're going to have our init function, just like that. And here we go. I kind of remodeled this app struct quite drastically here. So now we have our HTTP server, which is going to be our Fiber app, our database, MongoDB database, and a quiz service. And here we have our init function. So we start off by setting up the database, which we do down here. It's looking mostly similar to what we had before, but instead now we assign here to a.database. We just set the database from the database quiz. So just assign that to the database property and make sure here that you have a pointer to app if you want to change it. And then after we have set up the database, we create our services. So a.quiz service equals service.quiz, and I just change these to also be pointers so that I can conveniently set them in one line here. So we return a pointer from service.quiz here, and in here we pass in the collection. So collection.quiz, we return a quiz collection, and in here we pass in the database collection. So we use a.database collection quizzes. So we get the MongoDB collection. And then we assign all of that to a.quiz service, which we then can use here in setup HTTP. And this is where we set up our HTTP server, our Fiber server. So just do the normal stuff here. We do app, Fiber, new, and app.use. And then we also set up our quiz controller. Then we do controller.quiz, and then we pass in this quiz service that we created before. And now when we create this route for API/quizzes, we instead use this handler from our quiz controller struct. So we use this method that we actually have defined inside of our quiz controller. Isn't that neat? And then we do the same for WS controller, which will be our WebSocket controller. And we just do WebSocket.new and pass in that function here. And I just noticed, of course, we want to do a.http server equals app so that we assign it. And then after we have done that, then we want to listen to this HTTP server. So we just do a.http server and listen to that port. And I just noticed, of course, we want to use cursor.all here. We don't want to use decode since that would decode with only one element. So we fetch all of them and decode them then into a slice. Let's go ahead and try this out. If I just run this and do get quizzes, you can see it actually fails. And if we take a look at this, you can see error decoding key questions ID cannot decode string into an array. And that is because we have this custom type ID here, which is a UUID. And if we take a look into this, it's actually stored as an array under the hood. This is not something that I expected. I would expect them to have some sort of marshal or unmarshal for UUIDs. But I think the best way to go about this is probably just to make these strings instead. You won't really get this kind of strong type, but it's a bit difficult to work with. And I think it's better now to actually store this just as a string. It's much easier to work with. We could write our own deserialization and serialization, but I feel like that is a bit overkill for now. So I'm just gonna change this out into an actual string. And I also notice here for this ID, we want to actually add something known as a struct tag. You can actually annotate fields in a struct with a tag. And in this case, we're actually going to use the bson struct tag. So this is kind of the format. We specify the name here of the package. We're using bson. And in here, we're going to specify the actual name. So we want to have an alias. We could write this like underscore ID, but that doesn't look that great, right? So we want to actually use underscore ID as our ID field. So let's go ahead and put underscore ID here, and this will simply tell it's stored as underscore ID, but we unmarshal it into this normal ID name. We can see now we have our hello world. This one is actually null since we have 0 questions in that one, but I created another one for testing where we have some data. So we have our name, we have some choices. And let's also see if our WebSockets work. So if I press connect here, yes, we make a request to WebSocket, we see hello world, and we also send that. So we can see that that echo server is still working. Alright, so one thing that I noticed is actually that our struct tags are capitalized. So if I try this, so we can see that the keys here in this object are capitalized, and that's not something we want because that's not how our JavaScript expects it to be. So we can actually solve this by adding a tag to our fields in our struct. Let's do that now. And this is pretty much how that will look. So let's go ahead and try this again. If I restart the server, now we can see that the names are actually correct because we have the correct name in our JSON object, which we can also see here. We have everything with a lowercase, just like we would expect. So now let's go ahead and actually host a quiz. We want to be able to host a quiz from this UI as well. So let's add a button next to this quiz name so that we can host it. And here I am using Flexbox to get that with the help of a justify between. We will actually get the most spacing that we can get between the two items in our flex container. And of course we can switch this out to use our button component which we created. Now in order for this onClick here to work, we actually need to forward this to the parent component. And how do we do that? We just specify onClick, but we don't provide an event handler. So doing it this way will simply pass on that event to the parent component. So now we're going to let the parent component know that we clicked the host button in this quiz card. And we can do this by using something known as event dispatching in Svelte. We can actually create our own event dispatcher and send custom events with whatever names we want. And I also noticed here that the text is not centered, so let's add items center to center align that text. So now we can actually use our custom event here with onQuiz and pass in an anonymous function, and we will just call this host quiz function that I defined, but we will use the quiz variable that we get from the each loop. So let's go ahead and try that. We can see that we get an object displayed in our console, which is the quiz that we have clicked the host button on. So now we also want to be able to join the game as a player. We have currently this connect button, but wouldn't it be nice if we actually use a game code to join this game? So let's go ahead and implement that. So here I added an input field with the class border since the default Tailwind input does not actually have a border. So I added one, had the placeholder game code, and I also added a button called join game, which will call this connect function which we had from previous. And of course we can use our custom button component everywhere. It looks much nicer than the default button that we have now. So now let's actually go ahead and do something for this. Alright, so here I'm using two-way data binding, and I created a variable called code, which I'm using a bind value to. So this is actually known as two-way data binding. So when I update this input, it will actually change the value of the variable that I have bound it to. Isn't that neat? And of course, if the default value here wasn't an empty string, then it would actually be filled with that default value that I provided. You can see that we make a WebSocket request and we also send a join test, and we get back join test since we have an echo server. So that seems to work. So let's go ahead and copy paste this for the host quiz as well. We're gonna clean up this TypeScript code soon. We're just gonna have a different action here. So instead of this join action, we'll just use a host action. So let's go ahead and try that out. And now we can see we make that request again, but we also receive this host in our server. And we see that ID pop up there. So now it's actually time to get something working in the backend as well. Let's go back to our Golang backend and try to implement this. So here I defined a new struct called net service, and this will handle most of the low-level networking stuff. And it's passing quiz service as a dependency since I want to be able to get quizzes from this net service. So instead of that echo server that we had before, we're actually going to use the net service that we have. Now we're going to pass on that incoming message to the net service instead, which will actually handle it. And now in app.co we also need to provide this controller with our net service, so we need to create one for that as well. Now we can see we assign to net service, we create a net service, and then we also provide that net service when we set up our controller. So let's go ahead and implement this function on incoming message. So what I do here is simply convert this message into a string, and then we just print it to the console. And then I will split this string with our delimiter, which is going to be a colon. So the first part of the message will be the command type, and then we're going to have an argument. So we will have host and then the quiz ID, or join and the game code. So we split this into a slice where the first element is the command and the second one is the argument to the command. So here we're just trying it out with these two different commands that we have implemented. We just print out host quiz or join code. So let's go ahead and see if that works. And we can see that we get host quiz, and when I press this join game, we also get join code 1, 2, 3, 4. Isn't that beautiful? So here I defined a host field on our net service. We will refactor this later, but this is just for testing purposes. I define this host field, which we set whenever we get an incoming message to host the game. And then in the join game, I simply send a message to the current host to let them know that a player has joined. So let's go ahead and try this as well. If I now host a game, we will first host this quiz, and then I try to join with a player. And we can see if we go back here that we have a player joined. Isn't that beautiful? And of course I can join multiple times now. That is something we will fix later. So let's try to make a simple timer. I'll first define a tick field on this net service. And then on the incoming message, I will actually define something known as a go routine, and this will let us run a code on a different thread. Since we don't want to block the main thread, when we sleep here, we want to actually have a clock that is running on a different thread than the main thread. Let's also write something for this in our Svelte application. So I'm going to define a variable known as message. It will contain a message that we get from the server, and I will just set that message when we have on message in our host handler. So not the player handler, but the host handler. And then we just use curly braces to show that message. And then in our Golang code, we also want to send a message for each of these ticks. So we will send the current clock value to the host. And here I simply convert that tick into a string so we can use that, and then I convert that whole string into a byte slice. And then of course we also want our go routine to run in an infinite loop so that it will tick down and then sleep and then continue running forever. So let's go ahead and try that. So if I press this host button now, we can see that we get a nice little clock that is ticking down. Isn't that beautiful? And I can also join a game. I see that that message is displayed if I'm quick enough. So there we go, we finally have something to work with. We can finally start making our game. We finally have a pretty nice folder structure in our Golang backend. Today we're going to take a look at packets. Packets play an essential part in the communication between client and server. So what is a packet? Just like the name might suggest, a packet is like a small little container of data. These packets are what we're going to be sending over our WebSocket connection. Just like two people talking need to have a common language in order to understand each other, computers need one too. What do you think these ones and zeros represent? Maybe a bit of text, some audio, an image? The truth is, we can't really know unless we look at the actors responsible for encoding and decoding these messages, the client and server. The client and server will together need to decide which format they are going to use, and since we are programming them, we get to decide that. But I don't feel like we need to ditch our beloved JSON completely. It's a very versatile text format that evidently can be used for lots of purposes. We could of course pack bytes in the most efficient way possible, which you would probably do if you were developing a fast-paced shooter or something, but we're developing a pretty slow-paced game, so the overhead of JSON encoding and decoding doesn't really matter. And in return, our lives as developers will be much easier. This JSON text will then be encoded in a format known as UTF-8, which basically describes how a character or a letter is represented in binary. For example, how a letter like this A here will be represented in ones and zeros. We also need to have a way to identify our packets. Is this packet I'm sending here a connect packet or an answer question packet? And this is where we will get a bit more low level. Of course, we could just add another ID field to our JSON object, but this is a good learning moment where we might as well save some bytes too. So we're going to store a simple unsigned int 8 as our packet ID before the rest of the JSON data. Now what does this uint8 mean? I'm sure you heard of int before, a simple integer. Unsigned simply means that we don't care about the sign of the number that we are talking about. So we simply don't allow negative numbers for our packet IDs. The number 8 talks about the size of the integer, how many bits we're going to use to store this number. With 8 bits we reserve a whole byte, and since we only allow positive numbers then, we get a whole 255 different possibilities for packet IDs. So that's way more than we're going to be using really. So which packet types are we going to have then? When we connect to a server, we need to tell the server the code of the game that we're joining, but also the name that the player has chosen to play as. We're going to create a connect packet for that purpose. The host of the game also needs a way to, host the game. So we will create a host game packet which will contain the ID of the quiz that the user wants to host. Then we need to tell the host client about which quiz question to show. So we're going to add a question show packet. Now there are some other packets we're going to need as well, but let's just start with these. We also need to clean up some of the code in the front-end client, get a bit more structure going, So let's do that now. So I'm going to start by removing this counter component. We're not really using it anymore. So I created a new directory called model here, and this is where we will actually model our data. And I've just kind of followed the same format that we have in our backend, but written it in TypeScript. So we have some interfaces instead with all of these properties. And just like we have in our backend, I'm actually going to define a net service here, which I created in this service folder here. And here I've pretty much copied the exact same code that we have in app.svelte for connecting to the WebSockets server. So here I'm just converting this binary message here to an array buffer in JavaScript, and then I can create a new uint8 array, just like I said. So we have unsigned int8 array from this array buffer. So then we get all of the bytes that the message contained. And here we can simply read the first byte, just like you would do with an array. You can just do something like packet ID, and it will be the first byte. So since we have 8 bits, we simply have 1 byte for our packet ID. And then the rest of the message will be our JSON encoded packet data. In order to decode these bytes into a string, we can use the text encoder class. So let's do that. So this is how this will look. We just use the text encoder and the decode here. And important here that we actually use sub-arrays. So we start from the first byte. We skip the first byte simply. So the rest of the data here will be the JSON data. We just simply skip that first byte in this array and then decode the rest of it. And then we just parse that into a JSON object. Then we need to have a way to follow this format in our backend, and this is how we're going to do that. We first start off with a packet ID, which will be our uint8. I'm just going to set it to 0 for now, but when we have more packets in the future, we'll actually have to map this packet to a specific packet ID. So then we just marshal our anytype packet into a byte slice, which we get back from JSON marshal. If there is an error, we just return that here. And then we create this structure that I was talking about. We create a single byte slice where the first is actually going to be the packet ID, and then we pass in the rest of the bytes. And this syntax I'm using here is just because we have a multiple bytes. We want to add all of these bytes to the new slice, and we also want to add one packet ID. So we just have a single element byte slice here with the packet ID, and then all of the rest of the bytes in the other slice. And then we just get one final slice which we return from this function. And here I just define another function called sendPacket, where we will send a packet to a WebSocket connection. We first get the bytes from this packet, and then we just write a binary message to that connection. And I also go ahead and define a sendPacket method here in our front end. So just like before, we have a hard-coded packet ID for now. Then we just JSON stringify the packet data. And this gets a bit ugly, but I'm not sure if there's a better way to do this. We have 2 uint8 arrays that we would need to merge. So first we send in one with the packet ID, and then we have another one which we encode with UTF encoding, which we have from this JSON stringify as well. And then we have a merge array, so we need to specify the length of this array, which will be the length of the ID array and then the data array. And then we simply set these and we have to provide an offset here where we want to set it. So this is simply how we merge these two uint8 arrays, and then we just send that with the WebSocket connection. So here I have rewritten the onIncoming message method that we had previously. First we just check to make sure that there is actually a message coming in, it's not an empty message. So we need to be able to access this at least. So realistically this should actually be 2, since we need to be able to have access to at least 2 bytes. But here we have the first byte, which is going to be the packet ID. Then we just have the data, the rest of the bytes. And this is just syntax for where we start with an offset and we just use the rest of the slice. And then here we just create a connect packet. This is also hard coded. We will need to map this later depending on which packet ID is coming in. And then we just JSON on marshal that into our connect packet struct. So now we have handled encoding and decoding for both the client and the backend. So let's go ahead and try this. I replaced whatever we had here in connect with new net service.connect, and then here in the connection, when we have actually opened the connection, I send a new packet with code and the name, which is going to be the connect packet. So let's go ahead and try this out. If I press join game here, what will happen? Boom! As you can see, we get actually a struct back here which we are printing. This packet ID, however, does not seem to be quite that right? And that's because I was stupid. I had a 1337, which is actually a too high packet ID now when we're using uint8. So let's try something like packet ID 200 instead. Boom, now we can see that that worked. So just like I said, we are kind of limited here, but I don't think we're going to need more than 255 different packet types. So now let's actually stop hard coding these values. We need to actually provide packet IDs for our packets. So I'm gonna do it pretty simply here in the front end. So we have decoded here and parsed the JSON of this packet. So here let's just set packet.id equals packet ID. We'll just kind of forcefully set that property to be the packet ID. This means that we will be able to use this ID later whenever we want to check which type of packet this is. And it's pretty convenient. And down here we will need to specify the ID of this packet again. I think it is pretty nice to have a convention here that there is actually an ID property on each packet. So we would just do something like packets.id. Now this would include the ID in the message, which is not what we wanted. So we need to have a way here to actually remove this ID from the packet. And there are really 2 ways we could do this. We could set the ID of this object to just be undefined and then it will just disappear, or we could have something in JSON stringify. I think there's actually a replacer function which we can use to do that. So this is how we would do that. We get the key and value from JSON stringify. We check if this is ID, then we just set that, replace that to be undefined. Otherwise you just use the previous value. And then of course we need to include that here. So let's try ID 0 for connect packet. So here I'm going to define a new helper method called packet ID to packet. So this will take in a packet ID and spit out a new instance of that specific packet. So this specific packet ID 0 will map to connect packet. And then we can use that down here. So we just convert this packet ID to an actual packet and we check if that is not nil, if it's not an invalid packet ID, then we get back a new packet struct, which we can unmarshal. And then we do the same for the other way around. We need to have a packet to packet ID function where we take in a packet, which is struct type, and then we need to return the ID of that packet. And we can actually use something known as a type switch in Golang. So we can actually switch depending on the type of this value that we are sending in. So we can check if the type of this packet here is connect packet, then we return the packet ID 0. And we're also going to return back an error here. So if we got through this whole switch without finding an appropriate packet ID, we will just return an error called invalid packet type. So let's use this down here, packet to bytes. Instead we now use packets to packet ID. We get back the packet ID and an error. And if this error does exist, we just return an error instead. So let's go ahead and try this one as well. If I now send join game packet, we get open connection. If I go back here, something has broken. Right, it seems I messed up here with the JavaScript syntax. We can't use like curly braces here if we want to return immediately. So gotta get rid of those. Let's see if it works now. Join game. Boom. Yes, it does. So we can see packet ID is working here as well. So there we go, I just defined these packets that I spoke about earlier. We have the connect packet, the host game packet, and the question show packet. And I also defined these helper functions for that. So we have case 1, so we have these 2 packet IDs. We have 0 for connect packet, 1 for host game packet. I got rid of connect packet since we're not going to be sending connect packet to the client. We're only going to be receiving a connect packet. But we are going to be sending a question show packet. So for that one, we actually define that as packet ID 2. So now we can actually do something similar here on incoming message. We can actually switch here depending on the type of this package, but also assign to this packet variable again. So now we'll have it casted to the correct type immediately. Isn't that nice? So now we can immediately use name and code, which are defined for connect packet. And inside this case here, we can just use quiz ID since that is defined for the host game packet. Okay, I just noticed something here. We need to return these as pointers. Since we have the return type here as any, that type information will be lost if we don't send it back as a pointer. So we need to send pointers to these new instances that we create. Now we need to write that as a pointer type in the case as well. So a little bit inconvenient, but I'm sure we will survive. So now if we try this out, if I try to get quizzes and host here, we see user wants the host quiz, and then we see the quiz ID. And then if I try to join the game, we can also see that this name wants to join the game 1234, which I hard-coded here in app.svelte. So here in app.svelte, I'm actually sending these packets, the connect packet and the host game packet instead. And I also started connecting immediately when we render this component. So instead So I just got rid of that inside on open. We just connect immediately, and whenever the user presses one of these buttons, it will send the actual packet. So let's also try sending a packet back to the client. I'm just gonna create a new Go routine here since I don't want to block the main thread. So whenever we get this host game packet, we're going to create a new Go func here, and we will run it immediately, which you can see down here. And in here we will sleep for 5 seconds, and then we will send this question show packet. So then I define a new field here on packet callback in net service, and also define this method here on packet so we can set this callback. And then whenever we get a packet, we will just simply run this callback function. So now we can actually use this inside app.svelte as well. So we can do something like this, net service on packet, and we simply provide a callback function. And then we can do something. Let's try logging it to console. So then I will just try hosting this game and waiting 5 seconds. Let's see if something appears here. And boom, look at that. We actually get both messages. We have one debug in net.ts as well, but you can see app.svelte, we get back this, and we also get the data that I sent. Isn't that cool? So now we can conveniently use packet.id and check if the packet ID is 2. Then I defined a new variable here called current question, which we just set to whatever we have in the packet. Then I just create a little debug UI where we show the current question and all of the choices that belongs to it. So let's go ahead and try that. If I get the quizzes and I host this quiz, boom, won't you look at that? What is 2 plus 2? And then we have the choices 4 and 9, which are the ones that I'm sending here in net service as well. What is 2 plus 2? I could add another one if I wanted to. And there we go, isn't that really beautiful? So now we have set up a lot of our networking, a lot of the low-level stuff that will power our game, and we can finally start working on the game and get some sort of game loop running. Today we will focus on getting the game loop up and running. So what is this game loop? It's going to be that continuous thing running constantly in the background. We can kind of see it as the heartbeat of our game. Kahoot games, for example, have a clock that is ticking down. You know, there's a time limit for how long you can take to answer. This game loop will run on the server and contain most logic of the game. We will simply tell our dumb Svelte frontend what it should show and hope that it obeys. We're also going to need some states, which will say which part of the game is currently running. Are we in the lobby phase, or are we maybe revealing the answer right now? This state will determine what the player or host is going to see on their screen and what their allowed actions are. So we're going to have the following states: lobby state, play state, intermission state, reveal state, and end state. Lobby state will be when the game hasn't started yet and is filling up with players. And here we will show the names of the players currently connected to the game. Play state is going to be the main state, so to speak, when a question is up on the screen and players can answer it. Intermission state is everything in between, for example when we are loading a new question or something like that. Reveal state is going to be run after all players have guessed or when the time has run out. Here we will simply show the correct answer and cause that ruckus in the classroom. Finally, we will have an end state, which is, as you might have guessed, run after the game has ended. And here we will proudly display the winner of the game and maybe a leaderboard or something like that. So these are the states that I'm thinking of. We're currently going to represent them with a simple enum, an integer value identifying what the current state is. This is not quite built in Golang, but we can use the iota keyword, which will create a bunch of incrementing number constants. But in TypeScript we will just use an actual enum because that is supported. In the future we might refactor this into a more fully fledged state machine where the states themselves actually contain the logic for what is supposed to happen in the game. We're also going to need something known as a Go routine, and I've touched very briefly on this topic in previous videos, but I want to explain it a little bit further now. The Go routine is one of the most amazing features of Golang, I personally think. They let us work with concurrent programming in a very easy fashion. Traditionally we just have one thread, the main thread, and here the instructions are obviously executed in order. So what if we needed to wait a couple of seconds? What if we needed a timer? That would be very problematic if we only had the main thread to rely on, since we would have to block all the other code from running just to wait. And this is where we can use Go routines, which practically let us create a new thread to run code in. They are a bit different from operating system threads, but the concept is the same. If we run this sleep function inside a Go routine, that code won't affect the rest of our code. And this is what we will use for our game loop. Each game gets its own Go routine where it gets full power to do what it wants. So that should be everything we need to get going. Let's go ahead and write our game loop. Alright, so I went ahead and moved over this game.go file from entity to game. So this is where the actual game loop will live. And I also removed the current question integer since we are not really going to be using that. But other than that, it looks pretty similar. I also added a function here to create a new game from a quiz. So I just provide a quiz. We generate a random ID for it, and we also generate a random code. So we just use the standard library function for generating an integer, and we start here at 100,000 so that we can get a 6-digit integer. So here I'm going to define a Go routine. This is in fact just an anonymous function which I use the Go keyword to make a Go routine out of. And then I use an infinite for loop, which might sound a bit scary, but all we do in here really is tick the game, which I created a function for as well, and then we also sleep for 1 second. So this will just keep on running each second. We will simply call this tick function. We don't really need higher resolution than that. We are only going to listen for the clock really. So we're gonna have a clock that ticks down, and when that clock reaches 0, depending on which state we are in currently, we will display a different state or something like that. I will also go ahead and define a new field called host here, and this will be the host of the game, the actual WebSocket connection to the host client, which we just provide when we create a new game. So I just went ahead and defined a new slice here of games, and this will be the games that this server is actually handling. So just define a new empty slice here, and down here when we want to host a game, first and foremost we need to convert this quiz ID that is part of the packet into an actual primitive object ID, and we try to parse that. If it's invalid we just print out this error. Otherwise we try to get this quiz by its ID from our MongoDB database, and then we get back this quiz, and then of course we also need to check here if quiz is nil, then we want to return as well. So if we could not find a quiz by that ID, we also return. Otherwise we simply append to our games slice. So we have our game slice, and then we just append a new game where we pass in this quiz and the connection of the host. So I'm actually going to change this to be a pointer of game, since we want to be able to modify it. When we work with slices in Golang, if we wanted to modify a game in a slice, we would actually have to use the index of that element, and that is quite problematic. So in fact, I'm just going to store an actual pointer to a game, and then we can use this down here to get a game by its code. So we loop over all the games that we have in net service. We check if game.code equals the code, then we return that pointer, otherwise we return nil if we have not found that game. So then I will define a new struct here in game.go for a player, and this will be the name of the player and then the WebSocket connection of that player. And then we'll just have a slice of these players in the game, so that are all the players that are connected to this game. And down here we can initialize this to an empty slice. So then here in the net service, when we get a connect packet from a player, we first try to find the game by the code that they provided, and then we call this function on player join, and here we pass in the name that they chose and their connection. So then we can actually do something with this. We have the name and connection, and then we can append to our players slice. So we have the name and the connection, and we create a new player struct instance. And then since we are using pointers here, of course, we also need to use a pointer then when we have created it. So we actually append a pointer instead of just a struct instance. So let's also go ahead and change up here in app.svelte a bit. So we have this code here, hard coded, and the name. Let's just insert the code that we insert here, and I also created an input field for the name where we bind that to the name variable, which we use here as well. So let's go ahead and try this out. If I first get the quizzes here and I host this, we can see that we get a new game with this code. So if I duplicate this, I try to join it, join game, then we can see test join the game. So evidently it went through all of this here. So we get the game by the code and then we join it, and then we can see that test join the game. Isn't that beautiful? So then I will define this enum, which I was talking about before. It's not really an enum, but it's just some constants here where we use the iota keyword. So this first lobby state here will have the number value 0, and the next one will have 1, 2, 3, and so on. And then I define a type alias for that, just to have a game state type, which we can use here. So we have the state, game state. Now we initialize that with a lobby state. So I think it's time that we also define another packet. We also need to tell the host or the player which the current game state is, so that they can know what they should show. So let's create a change game state packet. It's going to look something like this. And we also need to define a packet ID for that. I'm going to choose 3. I also think it's time that we should define some interfaces for our packets in TypeScript as well. So let's do that. We have a change game state packet. So here I will define that enum in TypeScript. It will just have the same order here. That is quite important actually, that we have the same order so that these numbers here are matching. I'll also go ahead and define an enum here so we can conveniently map these to these types here. So in app.svelte, and I can instead use packet types dot change game state. If the packet type here is changed game state, then I just cast this packet into a change game state packet, and I will log that state. So let's also go ahead and try this in our backend. So now when a new game has been hosted, we will also send this change game state packet to the host connection. So let's go ahead and try this. If I get the quizzes and I host this game, everything breaks. Okay, seems to be something wrong with the connection there. Let's try again. Okay, now it worked out fine. Not sure what that was about, but yeah, as we can see now, whenever we hosted this game, we also get a lobby state sent to our client. So this will just be for debugging purposes. We are going to clean up this code definitely in the future. We don't want to put everything in this app.svelte, but just for testing now, I'm making an if statement here to check if the state is -1. So I created a variable here for state, which I also set whenever we get the change game state packet. Then we check if the state is 0, then we should show the lobby state instead. So now you can see if I press get quizzes and I host this game, we see lobby state instead, because that is our current game state. I think it will actually be problematic the way we have it right now, where game is part of its own package, because we really want to be able to communicate with the net service when we want to send packets and stuff like that. So I think we should move it to the service package, at least temporarily. We might refactor this later, but it will make things much easier now. Otherwise, we would have to have another intermediary package where we do some packet sending stuff, which might be nice, but let's just keep it simple for now. So we're going to make this like a service. We can't really use this nice syntax now since we're in a service package. We should probably do something like new game instead. Now we can use this with new game instead, so we just call this function, which is in the same package now. And we just call that game instead, since we had some conflicting names. But that should work the same way. The point is now that we can actually have some sort of field here which contains a net service pointer, so we can actually use that to send a package and such. And then we can pass in that reference. We have this C here, the pointer to net service. We just pass that into new game, which we set this net service to. So the point is that we can now use net service to send a packet also to the player. So the player should also know that the current game state is lobby. So let's go ahead and try this. If I host a new game, we get lobby state here. Then we can use this code to join this game. And boom, we can see we have a different views here depending on if I am a host or a player. And I solved that really naively here by just having a host variable, which I set whenever we host it. So if we are hosting it, we just set that to true. And then in here, if the state is lobby state, we could actually use game state here, I think, game state.lobby. So if state is game state.lobby, we check if it's the host, then we show this host lobby state, otherwise we show you have successfully joined. So now we kind of want to tell the host about which players have joined the game, just like we have in the Kahoot lobby screen, we actually show the names of the players connected. So I think we also need to identify our players by an ID. So here I'll also add some struct tags for these IDs and names so that we can send them over the network. But I will add a little dash here to make sure that we're not trying to send the WebSocket connection or marshal that WebSocket connection in JSON. We don't want to do that. So we just only include ID and name. So then I create this player join packet where we just pass in a player object that we want the host to know about. And we also define a packet ID for that. So here I define this interface player join packet where we have this player field, and we also define a packet type player join. So then when a player has joined the game, we also send them to the host connection that a player has joined the game, and we send that player struct instance. And for this to work, we also need to define this a little bit in app.svelte. So whenever we get a player join packet, we cast that over into a player join packet, and then we create a little ugly array here as well of the players connected to the game. We just add to that array with the current player that has joined, and then down here we show a list of all the players that we have connected to the game currently. So let's try this out. If I try to host this game, we can see lobby state, and we get a code. And then if I try to, with a name here, testing name, you have successfully joined, we can also see testing name show up here. So we can see that we get this packet here. I just noticed that this ID isn't that well defined. So when we create this player, of course, we want to do something like UUID dot new, I think. We should get a new UUID for that player. So now we actually need to have a way to start the game. So I'm going to define a new start game packet here as a packet type. We also need to define this in net service. And this will actually be an incoming packet. So we will send it from the client to the server. So we have to define this here and make sure that it's not taken by another packet ID. Then I'm going to create a function called start game where we just send that packet and a nice little button start game that we will show in the lobby state. So for this, I'm going to define a new function here called getGameByHost, where we pass in a host pointer to that connection. So we want to find a game in our games slice where the host is matching. And we need to do that because down here, when we get this start game packet, we need to get the game that this host is responsible for. So there are going to be multiple games running on the same server, and for example, we don't want a player to be able to send a packet like start game packet. We only want to find this game where this specific connection is the host. So this is how we're going to do that. So check if it's not nil, and then I just start this game. So let's go ahead and try this out. If I get the quizzes and I host them, and then I start the game. Boom, we can see that it starts ticking. I just added a nice little debug print here to say tick whenever we tick, and we can see that this game loop is working now. So our Go routine is clearly working, and I can still do other things at the same time. So I'm going to create a new function here called broadcast packet, and we're going to use this to send a packet to all the players that are connected to the game. We're also going to add include host, so if this is set to true, we will also send this package here to the host. And let's also do some error checking here. We'll check these send packet errors. If they do exist, we just return early with that error. So I'm also going to create a function called change state, and this will just change the state and then broadcast a packet to all players and the host to say that we have changed the game state. And that is in fact what we want to do here in start. So we want to change the state here to play state. So for this play state, we will show the current clock, which I will define soon. And then we just copied over this current question thing that I had previously just for testing purposes. If it's not the host, we just show press correct answer. And this is where we will have the buttons which the player presses to mark their answer. Then I will just define a new tick packet, which we will send to the host to show them the clock. So I'll define a new field here called time. I'm just going to set it to 60 by default. And then when we tick, we will just decrement that time field and send a packet, the tick packet, to the host. I'm going to define it here in packet types, and then we can use it in app.svelte. So case packet types tick. So when we get this tick packet, we just cast it over into tick packet and then set the tick variable. So I'm just going to define a little delay here. I think maybe that is what is causing that issue I had with connection. And then I'm also going to send a question show packet just for debug purposes. Whenever we start the game, we change the play state and show a first little question. So let's go ahead and try this. So I get the quizzes, I host the game. We can get the game code here. I try to join here. You have successfully joined. We can see test here. I start the game. Boom, press correct answer. This is the play state, and in the host we can see we have the choices that the player can choose from, and we can see that this clock is ticking down. So now we made some really great progress in our game loop. There's definitely lots of improvements, especially on the front end side of things, where we need to really clean up this mess that we have created. But we have finally gotten a nice little game loop up and running, and this is what we can build upon. So in the next video we will add the ability to answer these questions, we will have reveal states and stuff like that. If you've been worrying that our current design looks horrible, I must firstly agree with you, but secondly, it's time to change that. Now that we have our game loop set up, we can finally spend some time on making our app look better. The code in our Svelte frontend also looks pretty crap, so it's time to clean that up as well. The best practice when working with a front-end framework like Svelte is to create many components. Of course there's a limit, but it's often better to have more than to put everything in the same component. We create these components to be like small logical containers. They should do as little as possible, but do it well. We then group together these smaller components into a bigger one with similar responsibilities grouped together. Then of course we have our big boy app.svelte, but it should act as the ignition of our app rather than what we are doing right now, literally putting the whole logic of our application into it. In the last video we set up a bunch of game states such as the lobby state or the play state. It's sensible that we have one component each for these states, sort of like a view component, a lobby view, play view, and maybe end view. It's important that we separate these depending on if they're for the host or for the player. The player's lobby isn't going to look the same as the host, so we'll separate them into player lobby view and host lobby view. Then we're going to have two higher level components, a player view and a host view. We're going to use something known as the Svelte component element, and this lets us dynamically choose a component to render based on a JavaScript expression. We can set up this really neat object where we map a game state to a specific Svelte component. When this game state then changes, Svelte will reactively render another component. Super cool, right? Now we still have the problem that we can't really differentiate between the host view and the player view. How do traditional apps handle this? They show a different view depending on what the current route is. But this is a single page application, I hear you say. How can we do that? There are no other pages. We can solve this by using something called a router. There are multiple ways of going about this. If you were using SvelteKit, this would already be built in, since SvelteKit also has a server. With vanilla Svelte though, we have to be a bit more clever. What we're going to leverage is something known as the hash, which is a part of the URL. And this hash is traditionally used to focus on specific content on the page without making a different HTTP request. And we're going to use this to differentiate between the different routes and then the different views. There's actually a really great package that does this already, called Svelte SPA Router. We simply define an object with a bunch of routes mapped to a component which we want to render. Then we slap in a router component in our app.svelte and then we're ready to go. Super convenient, right? We will create the /player route and the /host route, which will map to our player and host view respectively. So now that we have a plan, let's write some code. So let's go ahead and install Svelte SPA Router with npm install. I will also create a new views folder where we will have our views. Here I will create two directories, host and player, and here we will create hostview.svelte and playerview.svelte. So this is how our routes object will look. We will have this root route which will map to player view component and our host route which will map to host view. I will also go ahead and comment out this bloody mess that we have here. We will replace it with a router component. And since our variable has the same name as the prop here, we can just use this shorthand. So let's go ahead and try this out. Now we can see that when we are in our root route, we get to see the player view. If I were to navigate to the host, we can see that we see host instead. Isn't that beautiful? So notice here that I need to be using this hash here. Otherwise, if I were to just do something like /host, we would actually get a different HTTP request sent to our Vite server in this case. But yeah, so when we just do this, we will get a single request to this root handler here. Then we will just choose component based on this hash value. So in this service directory, I will create a host directory and a player directory. And here we will have two classes depending on if we are in host mode or in player mode. So they will have their own separate logic for how to show the game, simply how to handle all the game logic depending on if it's a host or a player client. And both of them will be talking through our net service class. So I will also go ahead and create a packet interface which we will have for our packet objects. It is expected to have an ID prop and that will correspond to this packet type's enum that we defined. We can then use this here instead in our callback, and when we send a packet, then I will set up this constructor here where we instantiate a new net service, we connect to the server, and we also set up a callback function for when a packet is received to run this function inside the class. Then I will slap on this extends packet on all of our packets, since they are all expected to have this ID prop as well. I'll also define this host game packet, which we are using before with a quiz ID. And now we can start using this inside our host game. So we can use a host game packet and define that here, quiz ID, and that will be the quiz ID. And the ID here will be packet types.hostGame. So now we have a little bit better type safety here if we were to change this interface in the future. And what we're going to use here is something known as a Svelte store. If you have never worked with these before, they simply allow us to have a reactive variable that we define here in our TypeScript file, which we then can use in multiple places, pretty much globally throughout our whole application. So whenever this value changes, whenever we set a value here or update this value, it will reactively re-render everywhere where that variable is used. So that's super cool. So we're going to use this update function here on this writable. What we get here is actually a callback function with this parameter of the previous value of this writable. In this case, it's an array. And then we will just use the spread operator here to simply put all the other items that were previously in here in this array into a new array, and then we will just append another player to this list. So we're simply adding to a list here. So we're going to do something similar here for our game states. We're going to have a writable of game state. I will set the default value here. That's what we provide here. The default value will be lobby. Then when we get a change game state packet, we will just cast that and set that. So this will just immediately set a value without using the previous value. So here I went and defined a host quiz list view, which is pretty much what we had previously, where we would list all of the quizzes that we had in our database. I do it a bit differently now. So we have a get quizzes function, which returns a promise of a quiz array. We make the same fetch request, and if this fails, we'll just return an empty array. Otherwise, we will JSON decode that and return a JSON. And here I use an immediately invoked function. It looks a bit scary, but it simply lets us create a function and then we call that function. And we do this because we need to use async await if we're not using then. So we just use await here to get the quizzes and assign that to a quizzes variable, which we will render down here. And we can see that that works as well. So here I went and defined a little bit of styling. We just add a bit of padding. I add a nice little title and a flex container here. So we use a flex direction column here with a bit of a gap between these items. I changed up the quiz card a little bit as well. We just have a single nice little gray border there. So that looks much better for our host list view. And here we will use something known as event forwarding. Since we don't specify an actual handler for this event, it will simply be forwarded to the parent component. And in this case, that will be host view. So in here, I can use this on host. I'll also go ahead and comment out most of this code that we have here, since we're not going to be using it anymore. I notice here that we're not actually sending any data in this event. We're just simply dispatching an event. But we can send an event with the second argument here. So we'll just send in quiz and that will be forwarded here. So when we do on quiz, this needs to be an event. And we can get the quiz from the detail prop of this event. So I'll go ahead and instantiate this host game, which will handle most of the logic actually. It will immediately connect and set up everything to run everything for the host. Then we can use this here. So game.hostQuiz, and then we can specify this quiz ID. I also went ahead and defined this variable active. We need to check this. So when we host it, we actually want to set this to active. This will simply determine if we want to render this list view or not. So whenever we hosted a view, we will just show active instead. So let's go ahead and try this. If I try to host this test quiz, we can see active. And if I go into the networking, we should probably get some messages. I think we got a state packet, if I'm not mistaken. So in order to get the value of a store, in this case this writable here, we just use a $sign and just like normal when we have a JavaScript expression, we use curly braces. We can now see that the current game state is a lobby state. I will also go ahead and define these two components, host lobby view and host play view. So here I will use this really cool Svelte component element, and the current component that we want to render will be determined on what the current game state is. So here I define an object. It's currently complained because I haven't actually defined it for reveal and end yet. But we can see for the lobby view, we want to show the host lobby view component, and for play, we want to show the host play view component. So it will simply reactively update. Whenever state updates here, that will also update this value, so a different component will be rendered. I will also define a property here on this Svelte component to be the game, the actual game instance that we have here. And we will just take that in as a prop in our views so that we can use it. Then in the host lobby view, I will set up a nice little button, start game. And then we will use our game here to start it. I just define this to send a new packet with the packet type start game. So let's go ahead and try this. If I host this test quiz here, we can get into this nice lobby view, and if I start this game, we get play view. So we see that it reactively updated. Since we're now in the game state play, we now show the host play view component instead. Isn't that awesome? Then I will go ahead and define this player name card component, and this is going to be used in the lobby view to show the names of the players that have connected to the game. And I also added a nice little hover effect here, so whenever we hover over this, we're going to show line through, since we need to be able to kick players if they have offending names or something like that. And here I just use event forwarding as well, just to pass on that click event. So we also need to be able to join the games as players in order to test this properly. So I just went ahead and prototyped something very quickly here with Tailwind CSS. We just have a nice little PG purple background, and we just expand it to use the full screen width and height. And we use flex item center and justify center to center this content on the screen. And then we can just use a bit of styling on our title here, and a bit flex box again here for the input field. And here I will use a bit of padding and some rounded corners, of course. I will also define something very similar to our host game, but this is in fact going to be for the player. So very much exactly the same structure, but we will have very different logic inside of here. The point is that I can now use this here in our player view. So I kind of forgot that we also have player names, so I switched this out to be a column flex container, where we have the game code and the name, and we just bind these with two-way data binding to these variables, and then we can call this function join on our player game, where we send just a connect packet with that code and name. And I also noticed this is currently in the player view, but we want to move this over into its own component, so we're gonna have something like player join view. And yeah, I want this to be a prop, so we're going to pass in our player game, which we are going to define in a player view. So we're going to do something very similar here. We're just going to have a variable called active, which we check here. If it is active, we render this, otherwise we show our player join view. So we're going to have to handle something for this. We're going to use event dispatching. Now it's not actually sure that we are going to be able to connect to this game. Maybe this game code does not exist, for example. So this is something we will handle later. But for now, we're just going to dispatch as if every single join was successful, since it is successful really. So I will just bind to this join event here with on join, where we set active to true. So let's try this out. If I just try a random code, we can see that it already works, even though this was an invalid code. So then in our host lobby view, let's use our players store to render a player name card for each player connected to the game. And let's try this. If I try to host this, we can see we get a code here. There are no players connected currently. And if I try something like this, test, join game, boom, I want to look at that. We see our name pop up on our screen. Isn't that beautiful? And we show active here. So I will do something similar for our player game with this game state, define a store for that. And when we get a change game state packet, we just set that. And if we are now looking in a player view, you can see I added the Svelte component element, where we're going to use this state from our player game. Now it's important that we actually use the right import, since we have both the host and the player logic in the same application. So we need to make sure that we are actually importing the right version. So let's go ahead and try this. If I host this game again and I try joining it, we can see we have test added here, and we can also see that we have this nice little lobby view component that I created. Now if I were to start this game, we can see play view here and this empty view here, since I didn't add anything interesting to it, but we can see that it works. So I'll just add a handler for our tick packet as well, with a nice little Svelte store for that. So we just update that whenever we get the tick packet. I will also add the same for our current question. So when we get question show, I use this store that I created, a current question. This will be either a quiz question or null. The default value will be null. So here I went ahead and created the main play view, in fact, and this is quite a lot of code that I wrote right now, but it will serve us very well. So So here first check if the current question isn't null, and that is the store that we have here. And then I will have a min height screen, and this will simply make it fill up the whole screen. And then we have a flex container that is in column direction. And first here we have a header which will show the current question's name with a bit of different styling, a bit of a border, a background color, some text styling. Then we do a little bit of a hack actually. First and foremost, we set this flex one here. This makes sure that this will fill up all of the available space. It will make these only fill up as much space as they need. And then I have another flex container inside of this one. And in here, I actually put the clock to the left and then an image in the middle and then another element. This is just kind of a hacky way of justifying things properly. But here I just display a little rounded clock, and in the middle I put an image. Then underneath all of this is where I put the actual choices. So here we are going to have another flex, and this will be a flex wrap, which will use the full width and fixed height. Then I have defined these 4 beautiful colors, which are the main colors of our choice cards. And then I make sure that this width here is half, so it fills up half of the screen. So we will have 4 different choices and 2 per row. And then some other text styling here. And then I just pass in that color. And in the spirit of creating components, I also created now a quiz choice card, which has the same logic, but it's taking some props, that choice. And note this I here, we're actually using this to get the index of the current element. So we get both the element and on which place it is stored in the array. So we can use that there to get the choice. So let's go ahead and try this. If I host this and I join here, you can see that works still. And then I start the game. Won't you look at this beautiful little play view here? So here we have our 4 different choices. And in here we are going to put an image, but that is just like a placeholder text for now. Here we show the actual values. So these are the values that we have in our backend for our choices. And here we see the actual question name. You can see still nothing happening here in our player view. I'm actually going to move this colors array into our models since we want to use it from both the host and the player views. Okay, so I noticed we can actually reuse this quiz choice card a little bit better, but we won't actually use the choice here since that's not defined for the player. So if we get rid of this and put a slot here instead, I have shown how to use slots specifically here for this button. We can put some dynamic content in here instead. So in our host play view, instead of this choice, we will use a slot. So this should work the same way. So I just noticed that we had this padding here, PL14, in this component, which we don't want since we don't want that for the player. So use that another p tag here with that padding that we have from the left here. So let's go ahead and try this as well if I host this. So here we can see that beautiful view in action. We can see the same colors here. We don't see the actual choice names, but we see them when we look in the classroom or whatever. But here we are able to click them eventually. I just kind of did the same thing here. We just fill up the whole screen and we loop through the colors and use this nice component. And I use another button here to make it clickable with full width and full height. Now we haven't actually defined a way to answer questions, so we're going to have to move back to the backend a little bit and implement that. So here I define the question answer packet, and what we send here is just the index of the question that the player marked as their answer. Defined that packet ID 7 for it. Then I will define another helper function called getGameByPlayer. So we need to get the game that the player has joined. So from a WebSocket connection we loop through all of the games, and in these games we loop through all of the players, check if the WebSocket connection is the matching pointer, and then we return that game if it existed. Otherwise we just return nil. And we're going to use this down here when we get the question answer packet. We get the game by the player, and then we call this function on player answer with the connection, of course. So I think we might also make this a slice of pointers, since it will be much easier to work with. Instead of having to use indexes when we want to mutate them, we can just store them as references and we can mutate them directly. It will change down here a little bit. We just have to use an ampersand. I'll also modify this function a bit so we get the game by player and we actually return that pointer to that player as well if we can find it. So that will make things a bit more convenient here. So here we will just pass in the player instead. Here we have to return 2 nil pointers, of course. Then we will add another field to this player, which says if they have answered for this current round, which is what we will set down here. Then I will create another helper function called getAnsweredPlayers, and this will simply return a slice of all the players that have answered. So we just loop through them and check if they have answered, then we append to this slice and return it. So let's also define this in our front end. So we have the answer packet type. Then I will create this function called answer where we pass in the question and we just send that packet. And this is also what we will be using here in our play view. So when we have clicked on this specific little choice card, we will just send the answer to the backend. So let's go ahead and try this. If I try hosting this game and then I will set up 2 clients, and let's start the game. So let's try if I answer now, boom, one of the players has answered and now the second player will answer and boom, won't you look at that, all players have answered. And that is because I define this here. I check if the length of the answered players equals the length of all the players in the game, then all of the players have answered. So what we want to do actually when we have reached this state is that we will change to the reveal state, because all the players have answered, so we don't need to wait for the clock to tick down anymore. And we'll also do this here in the tick. So if we have reached 0 tick, we will also change the state to the reveal state. In fact, we can actually do something smarter here. So we only really want to do this if we are in the play state currently. So when we are in the reveal state, we actually want to change question, which we will implement really soon. So for the player, I'll just temporarily set this view to be the lobby view. But for the host view, however, we still want it to be the play view, since we're pretty much going to have the exact same view. The only thing that's going to change is actually the choice cards. We will show the color green if it's the correct answer or red if it's incorrect. So we want it to be the same view. So in order to show a different color if we are in the reveal state and depending on the choice, we create this function getCardColor where we just send in the choice, we send in the current game state for the host and the default color for what it would normally be. Then in here we check if the game state is not a reveal state, we just return the default color. Otherwise, if the choice is correct, we return color green, otherwise we return color red. So let's try this. If I press this button here, you can see they were in fact all incorrect. Is that true? Let's have a look. Yes, it seems I never defined that. This is just dummy data for now. Let's try making this 5-1 correct, or well, let's make the actual correct one correct. Let's try that again. If I press this one, yeah, we can see that it highlights the correct answer there. So in fact, let's actually use the correct data that we have. We actually want to use the data that we have in our database. I just updated it to have some more interesting questions. And for this, I will also define a current question, which will be the index of the current question. Then I created this nice little function called the next question, where we advance to the next question. We just increment this, change the state to the play state, set back the clock to 60 and send this packet to the host. And we will use this here instead of this hard-coded values. We'll just do a next question. And now we can actually use this here as well. When we have finally revealed enough, we can change to the next question. I'll also create a function for the reveal state where we set the time to a little bit less and change to reveal state. And yeah, in fact, we can use this here and down here. Now we must actually set this current question to be -1 if we want this next question to work. Otherwise, it will just increment past the first question, which since it is 0 indexed. So we start at -1. But let's go ahead and try this. I created this maths quiz and got rid of the older quizzes. And if I started this game, we can see we have what is 2 plus 2. These are the realistic answers. Press this one, we are going to fix this. We can see that is revealed and we can see it's ticking down. And boom, what is 7 times 5? We can see the clock reset and we get some new choices. You can see that also works for our reveal state. But unfortunately our game crashes when we reach past that state. So we in fact want to end the game whenever that happens. But that's all I wanted to cover in this video. We've gotten a long way towards working and pretty enjoyable game actually. So now we have a really proper game loop up and running and it doesn't look that crap either. There are definitely some improvements. This play view, for example, could have even more components for sure. And we also need to clean up some of the other stuff, such as ending the game and intermission states and end states and stuff like that. But I would say pretty much the core gameplay is here. We also need to have like a point system so that people can actually win. And we will actually implement a leaderboard. But in order to do that, we need to actually count the points that the player has. And we don't really have a way of determining points just yet, so it's time to implement that today. So we're going to start off by adding a points field to our player struct, and this will simply say for each player how much points they have gained. I'm also going to go ahead and implement this function reset player answer states, which will reset all the players to no longer have answered. Since if you remember, when a player answers, we set this answered boolean here to true, and we need to do that in order to check if all players have answered. And we want that to reset when we go to the next question. So when a player has answered, we actually want to first and foremost check if their answer is correct, but then we want to award them points. So I went ahead and created this get current question, which is just a helper function to get the current question. Since this is stored as the integer index of the current question, we just fetch that from the current quiz. In fact, we can also use this when we send the question to the host. So let's do that. So get current question. Then I also defined is correct choice, which will check if the specified choice index, which the player is sending, is a correct choice. And here we need to do a bit of checking, since the host could potentially be a hacker and send whatever they like. They could send something negative, or they could send something that is greater than the length of our choices, and then we would simply crash. So we need to make sure that it's in the range of our choices array, but otherwise we just get it by that index and check if the correct flag is set to true. So here I also went ahead and defined a little function for calculating how many points the player should be awarded when they answer. And I'm gonna go here with a little bit of a mix. We kind of want it to depend on the order of when the player answered. So if the player is the first to answer, we want them to get more points, but also a bit time-based. So if they answer very quickly, then they should have more points. So I just added something really quick here. I think we might need to tweak this later if we find out that it's not really working that well, but I start with 5,000. So if there are no other players who have answered, we simply give the player 5,000. So for each player that has answered, we simply subtract 1,000 times the amount of answered players. And yeah, this should in fact be 4. So I'm doing math.min here. It will simply provide us with the smallest value of the two. So if the amount of players who have answered is more than 4, then we would get into, 0 points or negative points, and we don't want to ever give it negative points. So this simply removes 1,000 for each player that has answered before. So the second player to answer gets 4,000, and the third gets 3,000, and so on. And that caps at 4 players. So for the 5th player and so on, we just give them 1,000 points. So everyone gets at least 1,000 points. Then there's also a small little time award here. So Simply use the time here to calculate how much of 1,000 they should get. So if the time is 60, that means we haven't ticked down even 1 second. So then we give them 1,000. So if we have half time, if it has ticked down to 30 seconds, well, then we will get 500 points. And then we simply just add them together. So this is something we definitely need to play around with, this little formula here, and find something that works. But this is, I think, a pretty good starting point at least. And here I just simply check before we set it to true. That's kind of important. Before we set the player answer to true, we check if it is the correct choice that they have marked, and then we award them that amount of points. I'm actually going to go ahead and add another field here, last awarded points. And we're going to use this so we can tell the player how many points they actually got. So that we will do after all of the players have answered. So I just set the last awarded points to get points award, and then we add that value. So then I will define this player reveal packet, which we will send to the player to tell them how many points they got. And notice we can just use this because if the player has gotten 0 points, then they would have answered incorrectly. So we can also use this to deduce if they answered correctly or not, and we can show like a red background or a green background if they answered correctly. We also need to give that a packet ID, of course, and define it here in packet types. So we also need to go ahead and send this to the player whenever the current round ends. Do that here in this reveal function. We loop over all the players in the game, and then we send this player reveal packet with the player's last awarded points. Let's actually go ahead and move this before the change state so that it gets in the order that we first send the points and then we change the state. So when we get this player reveal packet, I will just cast it like we did before, and I also defined a little store. So in this store we will save how many points the player got, and I also added a new view here, so a player reveal view. Very simple. We just have this full screen divider where we show the value of this points store. So let's go ahead and try this out. So if I start the game here, what is 2 plus 2? Well, it's obviously 4, so boom. Now we can see that I got 5,880 points. And this reveal state continues on. So now let's also show a view depending on if it was actually correct or not. And we can determine that by checking if points is greater than 0. So here I have a little reactive statement. I simply declare a new variable correct, and that is dependent on this points store being greater than 0. And Svelte will automatically update this variable whenever the points store changes value. Yes, I add a little curly brace here for JavaScript statement. I check if correct is true, then depending on if it's correct or not, I show either a green background or a red background. And then I also add flexbox here to justify all of this to the center of the screen. Then I also add a little bit of text here just saying correct and how many points were awarded, or incorrect if the answer was incorrect. So let's go ahead and try this out. So if I start this now and I press 4, I get correct. Okay, it doesn't seem like that worked. So this shouldn't be min height full, it should be min height screen. Yeah, right. Let's make that text white as well. And here, let's do 3XL, 2XL. So here 35 is the correct answer. Let's try that. And yeah, since this is flex, I need to put this in a divider. Let's also make this bold. Okay, there we go. That looks pretty good. Well, maybe we can do text center. Of course, due to the fact here that we only set last awarded points if they are actually correct. But if they are incorrect, it should be 0. So I answer correctly here, and here I answer incorrectly, and that works. Nice. So as you might have noticed, our whole server crashes when the game ends, and that's kind of a dramatic way to go out. So let's handle this when we attempt to go to the next question. So here I simply check if the current question index is more than or equal to the length of the quizzes, then we have reached the end. Then we simply call this end function, where we are going to set ended to true and change state to end state. So let's define that ended field. And the reason I am doing this is so that we can actually cancel this go routine. So if g.ended, we simply want to return here. So we simply break out of this infinite loop that we have going. So I guess it would make sense to actually display the leaderboard in between every question. I think that is what Kahoot does as well, so that the players can actually see who is in the lead and, you know, get actually motivated to try harder or give up if they are too far down, I guess. So let's implement that as well. So here we're actually going to use that intermission state that I was talking about. We haven't actually defined this anywhere, I think. So let's implement that. And let's also add that to our front end. Now it's important that these come in the correct order since they are actually, you know, indexed. So as we can see, this has the value 2 here and this also has the value 2 here. So that's important since we are actually sending that index over the network to say which game state it is. So then I define this leaderboard packet, which we will be using to send how many points each player has. So this will just be a map with the name of the player and how many points they have. So I will give that packet ID 9. Then I will also define an actual view for this. So we'll have a host intermission view. Let's add that to our views record. Then I will define a new store here in our host game with just a record for a string mapped to a number. I'll also define this leaderboard packet, which we will use here in order to simply set that to the leaderboard. And there should be points. So we just cast that and then we set leaderboard. Then I'll just have an each loop. I loop over the leaderboard and I destruct this entries of this record into the key and the value, which I name and points, and I'll just add a p tag for each of these entries. I think I'm actually going to lower this time here to 5. Then we will do something different here in the tick. So if it is reveal state and that has ended, we actually want to change to the intermission state instead. And when the intermission state has ended, then we want to actually move on to the next question. And let's set the tick here to something like 30. I think we actually want to let the host be able to skip ahead. So we're gonna have to implement that as well. Now this goes for 5 seconds. And absolutely nothing happens because we are not actually sending a leaderboard. So it's just ticking down, but we can't really see much. I'm actually going to define a function for this instead. So let's create one called intermission. Okay, I think I was being a bit stupid here since there's not really an order to a Golang map or a map in general. So I think we want to have some sort of slice of this leaderboard instead. So let's go ahead and do that instead. So I'll just define this struct leaderboard entry, which will have the player name and their points. And here we will simply send a slice of leaderboard entries. I'm gonna have to switch this up as well a bit. So here we have an array of leaderboard entries instead, and the same thing here. So here I define this get leaderboard function, where we will actually sort all of the players depending on their amount of points. So the player with the most points should here be in position 0 and so forth. And then I just create this slice of leaderboard entries, which we have. And here I do math min since we want to get just 3 entries. But if there are less players in the game, we only want to get at most that amount of players, or at most 3. And I simply append to this leaderboard slice with a leaderboard entry for each player with their name and points. I also switched up here a bit in host intermission view. Now you only have to loop over a normal little array, which we are comfortable with. And then we can use these fields on that object. So I think this should actually be the opposite order. So just want to do it in the right order that they are coming in as parameters here. But let's try this out with 2 players here, test 1 and test 2. If I answer correctly here and incorrectly here, this works fine. We get the reveal state, and then boom, we get a nice little leaderboard here. And then if I try answering correctly for the second player and incorrectly here, you see that still works. And we can see that test 2 has gotten a little bit less points since I was a bit slower to answer there. So that seems to work. Also, we have this white background here. Is that because we haven't actually defined a state here in the player view for intermission? But I think it's more reasonable that we still show the reveal view so that the players can know if they answered correctly or not. So for the player play view, we also want to add a little flag saying let answered equals false. We set answer to true. We set answer to true here when they have answered. Then I'm going to use this lifecycle hook on mount. So when this component is mounted, we actually want to set answered to false. I'm not really sure if it would work if I just set it to false like this, if it would actually reuse that when the component is destroyed. But since we are going to destroy it and mount it again, I think it's sensible that when we mount it again, we set that to false. Otherwise, we will be unable to answer the next time around. So I'm not really sure if this is necessary, but it's always a good precaution. So if they haven't answered, we simply show these choices cards. Otherwise, we show a nice little text. As we can see, that kind of worked, but the background should probably not be white as well, or just make the text color black, I guess. So here I also add a little bit more styling to our leaderboard or host intermission view, some nice rounded corners, a bit of different colors like this. So since we already have this start game packet, I think we can recycle it and use it for our leaderboard state as well, so that the host can just skip over that leaderboard if they don't want to see it. So this is pretty much how I want that to look. Just the skip button here and just the leaderboard here. I had to change a little bit here to remove the centering and add another component to center that one individually. And then I just use justify end here for that rightmost placing. So for this to work, I'm actually going to define the start or skip, which checks if we are in the lobby state, then we start the game. Otherwise, we just skip to the next question. So I'll also have to do this, change this up here. When we get the start game packet, we want to run start or skip instead. So now we are here. Let's see if skipping works. Yes, it does. It just goes to the next question and we can continue answering. Isn't that beautiful? So here I also defined a very quick host end view component where we just show game ended and the final leaderboard, final standings of the game. And here we can see who won the game as well. And I actually created a component for this since we want to reuse it between both the end view and the intermission state. So for the intermission state, we instead add this margin top in a parent element and just add a leaderboard component. And the same thing here. We just have some margin top here, justify center, to center horizontally. So there we go. Now we have finally added some leaderboards and a point system. So it's actually finally possible to win the game. And today we're going to finish up with creating an actual edit view. So you can't actually create or edit quizzes, which is kind of important if you are a teacher and you would like to use this application. So today we're making a quiz editor and adding some finishing touches to make sure everything looks pretty and works well. So I will be adding an edit view, and this edit view will be for a specific quiz. So if we go to our host view here, we can see that we have this nice little quiz and we can also host it, but we would also like to be able to edit it. So we're going to add an edit view where we pass in a quiz ID that we want to edit. And this is something we can do with Svelte SPA router as well. We can actually add params to our routes and then get access to that value. So this is how this will look. We will just add like a normal route, but then we'll use this colon here to denote that this is going to be a parameter. This parameter we give the name quiz ID. So whenever we visit something like edit / something, whatever we have here is going to be the quiz ID. And then we will simply render this component. So I created this view, edit quiz view, and this is how this works. We simply take in a prop. So we have a prop, we need to call this params, And this will just simply be an object of all the properties of all the params that we have in our route. In our case, we called it quiz ID, so we simply need to use that name here as well. But then we can show that here. We can display that on the screen. So whatever I put here, we can see is now being rendered here. So clearly it's working. So what we're going to do here is actually make a HTTP request to our backend to fetch a quiz by its ID. So we currently have a route to fetch all the quizzes in our database, but that's not what we want to do here. We want to target a specific quiz ID which we want to fetch the data for. So we're going to use that params quiz ID and then send a HTTP request to our backend to get a quiz by its ID. So I'm also going to structure this by creating an API service. So this is where we will make our fetch requests to our backend. So I created a new class here called API service with two methods, get quiz by ID and our old get quizzes method that we had previously. So now I can use that as well, but we also have this new get quiz by ID. And this will be the same thing. We will have API quizzes, and then after that we will just specify a specific quiz ID that we want to fetch. And then we just return that quiz or null. And now, since I exported this API service here, we can also use it in our previous host quiz list view to get all the quizzes. So here I'm also going to use that immediately invoked function. I simply create this anonymous function here, which I need to make async since I want to use this await keyword. But then I simply call this function immediately. So this will be ran whenever we simply fetch this script and interpret this script. So whenever that happens, we just run this and we get the quiz by the ID that we have specified in the route. Now, in order for this to work, we also need to define this in our backend. So let's go ahead and do that. So the syntax for defining a route with a param is actually the same here in our Fiber backend. So this is a pretty common way of doing this. We just specify this param with the name quiz ID, and we bind that to get quiz by ID, which I defined. And what kind of fun stuff happens here? Well, we get the param by the name that we specified here in the route. And then we need to actually decode this into a primitive object ID. So this is coming in as a string, but we want it to be that primitive object ID type. So we try to parse that. If there is an error, then we return bad request. Otherwise, we try to fetch the quiz by its ID. And here I actually noticed I'm not actually doing this properly. So if quiz is nil here, we actually want to return status not found. But otherwise, if there's an error, we return the error. Otherwise, we return the JSON of that quiz object. Now to the quiz service, we just simply forward that to the quiz collection, get quiz by ID. And what happens here? Well, it's pretty straightforward. We find one this time. So we find one instead of finding all. We have this filtering here where we get one by its ID. And we decode it into a quiz here. If there's an error, we return the error. Otherwise, we return a pointer. So that should hopefully work. So let's see if I try to stringify this. It will make a HTTP request. And we can see that this is actually a bad request since this is an invalid primitive object ID. But let's add a button here so that we can edit a quiz here. So here I just added another secondary container, which is also a flex container, where we add a gap between these two buttons, our custom button component. And here I actually use a function that comes from Svelte SPA router called push. And this will simply navigate to a new page programmatically without the user having to do anything. So we'll just force them to another route. So let's try this. If I press this edit here, boom, we can see that we get the JSON. And we can also see that we make a successful HTTP request. And yeah, we're getting the same JSON here. So I'll just make an if statement here, check if quiz isn't null, and that will display something here. Else we display quiz not found. So this one was not found. If we make it 7, we can see quiz since that actually exists. Now the way I'm thinking here is that we have some sort of sidebar here where we will have all of the quiz questions. So all of the quiz questions, you can click them, and then we will have like a main view here where you can see the choices. You can also see the question name, and you can also have like some sort of top bar here with the name of the quiz, maybe a save button. the ability to add new questions, delete questions, and stuff like that. So let's go ahead and implement that. So we're going to need something like this, a selected question variable. And this is simply the current selected question, and this will be null by default. So I'm starting out by making this top bar here, and here we'll simply have this input field. This will be the quiz name, and then we will have a save button where we can save it, and we'll make a HTTP request to save it. But the main takeaway here is that we do bind value. So we bind the value here to the quiz name. So whenever I write something in this field, because of two-way data binding, whatever I write here will actually be set in the object as well. So we will modify this quiz object. So I'm going to define a new component as well called edit sidebar, which will be this sidebar with the questions. It will just be a flex container, flex with direction column. We have gap 2, set little width here, make sure it's the width of the screen, or make sure it's the height of the screen, and a little bit different background color. So there we have that. I also added a flex container since we want to have first the sidebar here to the left and then some other content. So we'll use Flexbox for that. But we add an edit sidebar, and we can see that we have our items. I also made them p tags, but we can see that that kind of works. So I'm going to define a new component also, sidebar item, and this will be an item in the sidebar. It will simply be a button that the user can click to select that as the selected question. It will have background color white, a bit of rounding, a bit of padding, some border, also a little hover effect, but we also have this border color, and this border color will be dependent on if it is selected or not. So if it is the selected question, so we take in the question that this sidebar item is responsible for rendering, and then we send in the global selected question. So this is the global selected question of all the selected questions, and then we check, is this question ID that I'm supposed to render the same as the selected question? Then we show the border gray 500. Otherwise we don't show any border color except for the default here. And then we also added on click here. So whenever you click this button, we will simply set the selected question to the current question. So this will let us change the selected question inside of this sidebar item. So in order for this to work, we also need to bind the questions. And this is important that we use two-way data binding here so that we actually modify these values instead of just setting them locally. So whenever I change the selected question here, it will actually change this variable that I have here. And now we can see that that works. So now I can also select them. We can see them here. What is 2 plus 2? What is 404? And we can see that all of that kind of works. We can select the question. Nothing interesting happens here yet since we haven't added that. So I defined a new component here, edit question. And we simply check if selected question isn't null. Then we render this edit question component. Nothing interesting happening here yet. We just take in a prop of the selected question and we stringify that. So let's try it. Boom, we can see that kind of worked. I'm not sure what happened with the width though. Okay, so I changed this width here to a min width so that we really tell Flex that, hey, you shouldn't resize this. It should always be at least minimum width of 64. So now you can see that works a bit better. So what I want to do is actually mimic the user interface that we have for the play view when we actually have choices here and we can see some image in the middle, a clock, and the name here. It would be pretty nice if we could have like a website builder where what you see is what you get kind of vibe, where you can see the choices and edit them and, you know, see everything like it would kind of look if you were to play the game. So I'm gonna try to design something like that now. So this is pretty much what I came up with, pretty much code, but it's very similar to what we had in the play view. It's kind of different though, so I'm not really sure if we could make like a component out of it. We could definitely make some part of it. We could definitely make some parts of it more components and reuse them, but for now mostly copy paste this. So what we have here is just a lot of padding. We add with full flex 1. This then will be the actual interface. So we have first some padding around it, and then we have the actual box that we can see in here. And this will simply take up most of the space. This will be another flex container where we have a column layout. So first in this column layout comes this header, next comes this middle part, and then at the bottom here we have our choices. So that is our column layout here. So for this header then we just add, of course we also make it a flex container. We set a different background color here a bit. We make item center, add a border B here for the bottom border. We add a bit of padding, justify between. So this is kind of a hack, but I want to center this input field in the middle here and still have content on both sides. So I think the easiest way to do this is by adding some dummy container here with a fixed width. So we have fixed width of 32. Fixed width of 32 here as well, and then an input field in the middle. So this will simply space them evenly, add the space evenly between the items in the flex container. So in the middle we will have this input field, which is what is 2 plus 2, which is the selected question dot name. So here as well we bind the value to the selected question, and since this is two-way data binding, we are going to change in the actual object, in the actual quiz object that we have fetched from the backend. We're going to change that directly. So back in edit quiz view we will have an updated quiz object which we can very easily send off to the backend again. We don't need to add any extra logic where we set the value to something else when it changes. We simply bind the value. So this is really powerful usage of two-way data binding. And then to the right here we can see that we have a delete button for deleting this question. Then in the middle we just have a simple little placeholder image, nothing fancy going on there. And then at the bottom we have our beloved quiz choice cards as well, but they have been upgraded a little bit. So first we start with px14 to add padding horizontally, but then we also add an input field. So instead of just showing text here, we let the user actually change the value of this choice, the name of this choice. So here they can edit this, and of course we use two-way data binding. So we bind the value here to select the question, the choice here, we get the index from this each loop here. So we bind that to the name of the choice. So when I update this, it will also update in the quiz object. And then after that, since this is in a flex container, I added a checkbox next to it where we bind the checked attribute. So it will also change in the quiz object. Whenever I press this correct boolean here, our correct property of this object will be updated. So let's also implement this on the delete button. I think we're going to talk to the parent component here and say that we have deleted this the current selected question. So we're going to use events for that, creating a custom event dispatcher. Something like this, where we just dispatch delete. So here we will simply add on question delete, and we add this event handler on delete. So when this runs, we check quiz isn't null, then we filter the questions based on the selected question. So there will only be one question that we are deleting, and it's going to be the selected question, since you can't really delete any of them if you haven't clicked in on them. We filter out that selected question, and we also set the selected question to be null so that nothing is selected anymore. So let's try that. If I press delete, boom, we can see that it vanished. We see nothing here, and it also vanished from the list. So something that you might have noticed if you try this is that we try to edit this, it won't actually update here. And that is because, well, it will update the actual object, but Svelte will not have known that this specific quiz was updated. So what Svelte listens to here is actually this quiz variable that we have. And Svelte doesn't know that it has updated since we are so deeply nested inside of it. So what we need to do here is a little bit, it's a Svelte quirk, so to speak. So whenever this value changes here, we're simply going to forward that to the parent component on change. So in edit quiz, we can do something like this. So on change quiz equals quiz. This looks a bit silly, but this quiz actually contains the updated value. And since we use an assignment, we simply say to Svelte, hey, something has changed. It's time to update and show that new value. So let's try that. What is 2 plus 2? If we change it to what is 4 plus 4, and I press enter, we can see that that updated, so it works. Now we can also see that all of this persists, of course. If I add 4,000 here, I uncheck that and check that, and I click this and I go back, we can see that of course these values are persisted. I think it would also be nice if we could change the time limit for a question. Let's say if we have like a really tough question, what is maybe what is 1337 times 666 or something? Maybe a bit more time required than for example, what is 2 plus 2? So, you know, questions have different time limits. It would be nice if we could change that. So let's implement that. And of course, since we have what you see is what you get, wouldn't it be nice here to have like the clock, the actual clock that we have in our play view show up here as well with an input field inside of it? So let's do that. So this is the clock that we have, this divider. So let's go ahead and make a component out of it. So we're going to use a slot here. I've talked about this in the previous video, but we simply put all the content inside of this component. Just like we have our custom button component, everything inside of the tags will be rendered here. So we're going to put a slot here. Then let's get rid of text3xl, since that doesn't really apply when we have an input field. Otherwise, we just have the same code that we had in our play view. We can in fact actually use this in our play view. We can add a nice little span, and this is why I talk about the slot. This is what we render inside the tags here. So just a simple span with the text3xl, which we had previously. And now we can also use this clock component in our edit question. So this is actually not part of our model yet, but let's add it. So for the quiz question, we also want to have a time, and this will be the time limit for this specific question that the users have to answer it. And let's also add it in our backend, like so. So this is pretty much what I'm thinking. It doesn't look that nice right now since I have such a small window. But if you see, if I enlarge it, we can see that nice little clock. It's actually undefined now since these don't actually have a time limit and the backend hasn't been restarted yet. But what we want to do here is actually use a normal value. So we can't really use bind value here because we want this to be an actual integer value, and the type of this input field is actually text. If I were to make it an input type a number, we can see that we get this really ugly spinner-like component, which doesn't look that good in my opinion. So we're gonna need some custom logic for this, in fact. So we can do something like onChange for this. So here is how I define that. On time change, we take in a generic event. Then the target, e.target, gives us the target HTML element where this event occurred. We simply cast that as HTML input element, and then we set the time to parse integer from the target value. So I added this time field now to my MongoDB database, and I restarted the server. So here we can see some of the values getting through here. If you haven't added any values to your database, it would still be 0 since Golang has default values. So the default value of an integer is 0 in Golang, so it wouldn't be null, it would simply be defined. It will just be 0. But now I have some values which we can use. I also added this add new button to add a new quiz question. Simple button where we append to our questions array with a new question. We just add a lot of these choices since they actually need to be provided if we want to render them properly. So we have 4 choices, all of them are incorrect. We give them random IDs, different IDs, that is important. And the name here will be an empty string. So you can see that also works. I set the default name here to be question. And I can edit this. The default time for this is 60, which I defined here. So I guess it's time that we actually save this to our backend. So we need to implement that as well. So I defined this save quiz method to our API service, where we take in a quiz ID and a quiz object, and we make a HTTP request to exactly the same thing as we do up here. But this time around it's actually going to be a put request since we're modifying an existing resource. And here for the body of this HTTP request, we JSON stringify our quiz. And here it's important that we set the content type header, since we're sending off this as JSON. For this to be processable by our backend, we need to set the content type to be application JSON so that it knows to expect that. And if this failed, then we just alert fail to save quiz. And now we can finally use this inside our edit quiz view. So we're gonna send this here in the save function. So whenever we run this, we check if quiz isn't null, otherwise we run a save quiz. So of course we need to define this in our backend. We add app.put, since that is the method and the same route. And then we need to define update quiz by ID. So this is how that is going to look. I first define a new struct, in fact, an update quiz request. So we could of course just decode directly into our quiz struct, but then the user could actually edit this ID if they wanted to. They could actually modify the ID. And imagine if we had other important properties here, maybe like a password or something like that. Other important properties that we don't want to be mutable to any outsiders. So here I simply define very strictly what is the client able to change. So we will have to have some manual code, of course, but this is pretty good now since we don't have a lot of fields. If we have a lot of fields, there are some other techniques that we could use. But I just pretty much copy pasted the name and the questions field. And how do we do this? Well, it's very similar to up here. We parse the quiz ID. Then we're going to use something known as the body parser in Fiber. So Fiber actually has a built-in functionality for parsing JSON and XML and I guess a bunch of other types, content types. But here we can actually body parse into an actual struct. It's pretty fascinating. So we can use body parse, and of course, since I talked about this previously, we need to make this sure. We need to make sure this is a reference so that it can actually modify this specific variable that we have here. So we body parse the incoming request, the incoming body, which is JSON, into this update quiz request struct. And then we call quiz service update quiz, where we send in the name and the questions that the user wants to update. If there's a problem, we return the error, otherwise we return status OK. Then for the update quiz function, well, here we just try to get this quiz by ID first. So if it does not exist, we simply return that error. Otherwise, we take the existing quiz, since we have that object now, and we replace these properties. We replace the name and we replace the questions. And then we call update quiz on quiz collection. And how does this look? Well, here we're going to use some specific MongoDB syntax. So we're going to use the update command to update a document in the collection. Here the first argument is the filter. So we want to get the document where ID equals quiz.id, and then the second here then the second here is actually the update document. So instructing MongoDB how it should do something, and set simply replaces the whole document. There are other things you can do in MongoDB. It's pretty powerful. You could add to an array or set a specific field like deeply nested and stuff like that. But we simply replace the whole document, and we replace it with this quiz object. So the driver will just simply marshal that and handle it for us. We just need to pass in the object. And this should actually update our quiz in the database. So let's try this out. If I go ahead and add some question marks here and press save, let's see if that is successful. We put that. And if I reload now, we can see, boom, that has been saved into the database. We can know that because we're actually fetching it from the server again. If I were to restart the server, boom, it's persisted. No black magic here. It's actually saved to disk in my database. And we can of course change the quiz name if we want it to be maths instead. Save that, boom. That is also persisted. And all of this is beautifully done with two-way data binding. So I can just add questions and save, and boom, it will just update according to that object, according to that quiz object that I have. Isn't it fascinating how easy that is? So now we pretty much have our quiz editor finished. So let's also add some finishing touches to this project. We currently have this host lobby view and it looks pretty dull, right? We don't even have the game code shown here. We have to read it from the console, which is really stupid. So we need to have a way to see the game code. And the way I'm gonna do this is by actually reusing our host game packet. So this is sent by the host to the server to host a quiz by its ID, but there's no reason we can't just reuse the same packet here, but use the quiz ID as the code instead. So this will be a bidirectional packet. We will send it both ways. Who cares? So whenever we host this, we will simply send that packet to the host as well with the game code that was randomly generated. Now for this to work, we of course need to add it here as a packet ID. It is defined here, right? It's defined here as packet ID 1. So let's add it. And of course it's important that it's the same packet ID since that's what's going to map in the front end. So host game packet has packet ID 1. So whenever we get a host game packet from the server, we decode that and we set this game code store. So I'm going to add a new store called game code. Which will just contain the game code. So this will actually improve our design a little bit because now we really only go to the host lobby view whenever we have a proper game code to join. If somehow the hosting failed, maybe it was an invalid quiz ID or something, then we would not get a game code back. So instead of this stupid active boolean, we will simply check if game code isn't null. Then we render the game. So I also changed up the design here. I added a nice large join with the game code and even larger I display the game code so that the players who are in the back of the classroom can see it clearly. Then I also added a bit more styling here so we show how many players have joined. And we also show no players have joined if there are no players who have joined. And this is a fancy little syntax from Svelte. So if there are no elements to iterate over in each loop, we simply use else. So each or else, if there are no elements in the array, we simply show no players have joined. So let's try this. If I try to host this, boom, join with game code. Players, no players have joined yet. Doesn't this look much better? So one thing I'm also thinking of is if a player has disconnected, we are not actually removing them ever. So we need to implement disconnection functionality as well. We can do this here in the controller. So whenever we get an error from read message, that simply means that the connection is faulty or that the player has disconnected. So we can use that. So if there is an error, then we can tell net service that the user has disconnected. So we simply add c net service on disconnect and send in the connection that has disconnected. And that is how this will look. We try to get the game that the player is a part of. If it doesn't exist, we just return. Otherwise, we get that game and we tell the game that that player has disconnected. So here we have that on player disconnect. We send in this player pointer. This looks pretty ugly. We could probably write a utility function to filter a list, but we just loop over the current game players. And if it is the player that we're trying to remove, we don't add them. Otherwise, we add them to the list and then we just replace the whole list. We then send a left the game message. So all that remains is to tell the host that a player has disconnected. So we're going to need a new packet for that, a player disconnect. And this is how I will define that. Player disconnect packet. We send the player ID of the player that has disconnected. And of course, we add a new packet ID 10. Let's also add this here to packet types. And as an interface here, player disconnect packet. And then we can use it here in the host game. So when we get a player disconnect, we cast that as player disconnect packet, and then we update our players store. And of course, we also need to send it whenever they leave. So if I try that now, if I host and I try to close this tab, boom, instantly we get that removed and see no players have joined. So let's test the flow a little. If I join here and start the game, what is 2 plus 2? 4, correct. Reveal state, skip, what is 7 times 5? Well, that is 35, correct. You can see a nice leaderboard. What is 404? Both of these are in fact correct. And these are our dummy choices with nothing correct, so this will be incorrect. So there we have it, game ended. I think it would also be nice here if we added a bit more fancy medals or something. Maybe a little gold icon for the player who won the game or something like that. And something that is remembered. When we go to the reveal state, if the player has not answered whatsoever, we also need to set that last awarded points to 0. So if they didn't answer at all, they just didn't vote, so to speak, then we set it to 0. So that's like an incorrect answer. That's really important. Otherwise, they will think that they have correctly answered, even though they didn't answer at all. And boom, doesn't that look much nicer? So I just added a nice little finish flag. So this, since we are reusing this component for 2 scenarios, we only want to show these medals whenever we are actually in the game end state. So if it is finish and we have less than 3, so if there are like place 5 or 4 or whatever, they won't have any medals. Then we show that medal. Then we have some of the colors here. So we have kind of gold-ish yellow, more yellow than gold. Then we have silver, and then we have BG yellow 700 for a brown color. We can also try this if we do I+1 here. We can see silver here, or the bronze that I came up with. But I guess we actually want to include more than 3, since we still want to show the place that the players had. So if I is less than 3, then we show I, otherwise we show 2. So this will simply show the brown color if they are another place. So if I were to do something like this, maybe it would show the brown color. So yeah, if we had more players, if we had like 4 or 5 or even on, then they would have the brown color, but still show the standing on which place they came. So now if I quickly edit this, this has 5 seconds. Let's make this 20 and add 2 choices here, A, B. Let's get rid of this last one. Save that, boom. Then we can go back to host and host it and join it as a player. We can see our name here, players1, start the game. What is 2 plus 2? That adds 60 seconds. If I do 4 here, boom. Let's see, this should be like 5 seconds. So we have a leaderboard, skip. That should be 5, right? Wasn't that 5? Yeah, we haven't actually set that. We haven't actually set the time limit for the question. So we want to do that in the backend, of course, as well. So when we go to next question, we want to, instead of setting it to 60, we want to get the current question and set it to the time. And here we can reuse that for the packet. So let's try that once more. Host this game and try to join it, start it. What is 2 plus 2? That was 55 seconds, so it clearly worked. If I do 4 here, boom, we have a reveal state. That works fine. We have a leaderboard, no medals or anything. And we skip that, boom, 5 seconds. I will leave out my answer now. And boom, we can see that it shows incorrect. Nice. And then we see the correct answer. Still leaderboard. What is 404? That was even shorter, maybe. Yeah, it was even shorter. Still incorrect. Let's see if I answer correctly here. That was correct. So now she had pretty much 10,000 points, 11,000. Skip that one and boom, the game ended. We can see the final standings. We can see that test won here with 1,072 points. So there we go. That is pretty much what I wanted to implement for this project. That is what I had in mind for my Kahoot clone. I hope you guys enjoyed this series. Of course, if you have any suggestions of anything else you would like to see, some specific features, make sure to comment that. And maybe I will make a compilation video with all of these features and implement them in the game. Feel free to share your projects if you have finished this and made it a thing. That would be really cool to see how your quiz Kahoot clones differ from mine. But feel free to join my Discord channel if you want to be part of the community, and feel free to subscribe. But other than that, I'll see you guys in the next video. Peace out.